Ah, I haven't seen the button. Thank you. Hello, everyone. Please have a seat. We will begin. We are slightly in delay. Okay, so good morning. We'll begin our midterm evaluation workshop regarding the projects which was selected in the framework of the first call launched within Pillar 1 of LIPRI. The call was launched in 2021 and we selected the project in 2022. So these projects have already around 1.5 year, 1 year, 1.5 year implementation duration. And so today, the goal is to report on these projects, the first results and the perspective. As I said yesterday, but for those who were not there for the kickoff meeting of the second call, we have in the room the speakers and the coordinators or the representative of the coordinators of each project, some in line, but most on site. And we have also some evaluators who participated to the evaluation of the project before the selection. And we have members of the Scientific and Ethics Advisory Board here, and two representatives from the European Commission and the STINE agency funding the project and the program. So we will begin right now. The format is 20 minutes of presentation for each project and 10 minutes for questions and answers. So the first project, the first session, we tried to gather projects with thematic issues. The first session this morning is regarding cooking, clean cooking, and biomass utilization. And the first project presented is Sungari, and it will be presented by Mamsai Diale, who comes from South Africa and representing the coordinator. So, Mamsai, if you could come here. Just there is, you have to ask for changing slides. Go ahead, go ahead.
Yeah, yes. This is for me, it's not for the slides. Slides
Yeah.
are there.
So when you change slides, you say next slide.
Okay.
Okay.
All right.
So you have the floor.
Good morning, colleagues. When I came here this morning, it was like I'm lost. There was no one. So now everybody's there. Thank you. My name is Mamsai Diale from the University of Pretoria in South Africa. I am the coordinator of the Sungari project in South Africa. I'm actually a South African research chair in clean and green energy at the University of South Africa. So, and I have different other projects that I do in solar energy, hydrogen, and in addition, just in a nutshell, I also teach financial managers at the banks how to sell their photovoltaics to take the renewable energy to the next level. And I also teach the government, municipal managers on how to transit from fossil fuels to clean energy. Then also the pricing of electricity and gas. Thank you. Okay. Oh, there's nothing I can read from here. Okay, you can, what is the first slide? Okay. All right. The Sungari project is a consortium of, previous slide, please. Okay, good. It's a consortium of the people from University of Kassel in Germany, and then Simply Solar Technologies in Germany, University of Pretoria, University of Limpopo in South Africa, which is a requirement for South African projects that you have to work with another university, which we call from disadvantaged background. And we also have a technology partner, Delphius Technologies, who is part of the South African team. And then we have University of Lomé in Togo and University of Greenwich. And the aim of the project is to develop a modern energy cooking services based on solar cooking, using photovoltaics and concentrated power for a staple food in West Africa called gari. Gari is a product that comes from cassava leaves, the cassava root is grated, and after grating it, it is fermented, and after fermenting, they dry this gari. Next slide, please. These are the countries, transcontinental partnerships on renewable energy. You can see UK, Germany, Togo, South Africa. And the objective is to co-design and develop transferable and scalable solar-powered cooking device for gari roasting. So the impact of this is to produce good health and well-being, affordable and clean energy, climate action, industrial innovation, gender equality. When you look at the SDGs of the United Nations, and then the Africa-Europe long-term partnerships, and then establishing a Sangari startup in Togo. Next slide, please. So what happens is that engaging gari with processing units that is demo sites at in Togo will, at the domestic and SME level, to conduct temperature and energy optimization for comparative analysis. I can see that we have not put a slide in that really explains what this gari is. Let me go back to this understanding of what gari is. So you take cassava roots, and then you cut them, and then after cutting them, you ferment whatever the product is. And after fermentation, you produce the fermented product, you produce this powder called gari. So this powder helps to preserve gari, that is, it's a kind of storage. Because if it is just the cassava and then you produce it, just use it immediately, there is no storage. So the storage here comes in the form of this powder. And this is a staple food for people in West Africa. So we have tried to do a little bit of this, and it is a little bit of a soury powder, which they produce a staple food like your rice, or yeah, in South Africa there we have got also something similar to that from sorghum. Okay, so I hope I have explained it better, because I don't see the where we have gone into explaining what this is. So I must not take it for granted that everybody knows what we are talking about. So if you look into that picture, that's how this gari is produced. Women sit under a shade, they use wood to dry this gari, and they continually stir it so that it is not sticking to your pan. So that's what we want to work on. That's the aim of this. So the work is to produce a vessel, an aluminum pan, where it has a motor, a stirrer inside, and then you have a motor that you can connect to your electricity. and then it works itself. So if you look at this picture there, you can tell immediately that there is an issue with the health of those women who are working with this. They inhale this smoke, they have children with them there, so you just don't know what type of diseases will develop with this kind of production of gari. So the aim of producing this motorized aluminum pan connected to electricity is that even small households can use that to dry their gari, to dry the fermented product into gari. It only becomes gari when it's a powder. Okay. So the design and construction and performance and evaluation of these 3 types of solar gari roasting devices, that is, the 3 there is that you want to use electricity, you want to use steam, you want to use PV, but all this electricity comes from concentrated solar or photovoltaics or steam, but all from renewable energy, not using your fossil fuel or your normal grid electricity. So undertaking a socioeconomic analysis, including financial feasibility and ease of handling operation and marketing strategy for the devices. So after producing the devices, we are looking forward to seeing the devices being used widely by anybody, just like your electric kettle. You go to the store, you buy your electric kettle to boil water, you go home, you use it. So this is our aim of producing this kind of device for cooking purposes. So, and also we want to training of cassava processing equipment manufacturers, local, regional, that is in the West Africa as our capacity building aim. So when that is done, you want people to be able to use these pens with ease without getting any confusion. All right, then, so you look at the scale down there, the cassava value chain for gari production. So you start with small-scale cassava farming, and then you harvest the root, and then there's peeling of this root, just like your normal sweet potato. I think many people know this one. You have to peel the cassava, and then you grate it, and then you put it in a container and ferment it, and then you roast that. They call it roasting, but you're actually drying the fermented product so that you produce the product called gari. Next slide, please. So design of and construction of sangari roasting devices. That's what we call it. Sun for the sun and gari for the powder as a complete device. So the pens that you see at the bottom, steam gari pen, has been manufactured in South Africa. The project thus far is already manufactured. These aluminum pens have been manufactured by a private company called Delphius Technologies in South Africa. So we are the process of sending it to Togo so that they can start working with the aluminum pens. And then the site is already selected in Togo at the University of Lome, where you are going to put this pens, and then become a place where you are trying the pens and making sure that everything is working properly. We have already done the calculations at the University of Pretoria about how to deal with the amount of heat that would need, heat capacity, for the drying of the gari. For example, it will depend on the moisture that is in the fermented product, and it will also be controlled by what temperature you're going to use, and for how long, the time. So all those parameters, we are still working on them, and then we want to see on the ground in Togo if our parameters are coming out easily. So also the consortium, the group in Togo, they have already asked what type of solar panels they want to use. So we have given them the parameters that are necessary for your solar panels so that you can be able to get a maximum output out of the project. So the solar thermal concentrators that you see there, they have been manufactured in Germany by Simply Solar, and they are ready to be installed at the demonstration site in Togo. Next slide, please. So our expected outcomes in case of the project success by 2030, we want to have optimized gari processes, innovative solar cooking device for gari roasting in West Africa, improved collaboration between Europe and Africa, technical and managerial capacity building, training, which is human capital development, scalable and transferable technology, that is, this pens must be produced en mass so that other people can have access to that. And then the socioeconomic feasibility, think about the women who are supposed to waste a lot of time producing this gari. Think about the girls that, you know, in certain communities that are expected to take time from their growing as young people in being in the work of producing this gari powder. So, and we want to have a startup called Sangari, which will be in Togo. So every one of us must just think about the process of cooking. You know, in an African village, you have to go out and collect the wood. And then when you have collected the wood, you go out and now start the whole process. It's all the time that is wasted on the energies of a woman. Next slide, please. So our contribution of the project to the AU-EU Research and Development Partnership, introducing an efficient, scalable, and transferable solar device for gari making, and supporting the transition of African economies to be low carbon and climate resilient. Renewable energy systems to support economic growth and development in Africa, and the collaboration between Africa and European scientific communities, South-South cooperation via technical contribution, exchange of expertise among African partners like South Africa and Togo. We hope we will produce a better relationship, a better working together, and producing all these nice devices. And then interest of consortium members in participating in the Lely Paris clustering is the cleaning, cooking, biomass transformation, process-wise evaluation of specific energy demand for traditional cassava production, and gelatized many hot processing techniques. So we have a PhD student called Moape Chikololo, who is from Zambia but is based in Germany, will be presenting his work today during the day. Thank you. Next slide, please. Okay, that's the end of the presentation. I hope I have been able to manage time properly. Thank you.
Okay, thank you, Mam Sage. Thank you very much for this presentation with a nice picture in order to understand better the project. So we will take questions. Yes, Gundula. I don't know, we don't test this morning yet if there is microphone for the room. yesterday we asked you to come here, but it was, if we could manage it, it will be better.
Hello? Yeah, I think it's laudable enough. Let me commend you for the good work. Actually, the roasting or drying of gari is a very difficult process in West Africa. I'm from Nigeria. I know what it goes through. But we have a challenge. I don't know whether you looked at that aspect of taste, the taste of the gari after processing. Because in my university, we did also a similar project where we use mechanical systems to dry plantain. And at the end of the day, the acceptance of that project by the people in terms of taste was a very huge concern. They now went back to also buying the plantain roasted with firewood, saying that the wood also add a little bit of taste to the process. So I don't know whether you have to consider that too in your research. Thank you.
Thank you.
Actually, on Tuesday, I asked this question. I hope people remember the question that I asked when the people from Kenya were presenting on the cooking device, and I said to them, what about the taste? You are very right. The communities are still resisting. They say the taste is not the same. I'm one of them. Think about, in South Africa, we call it braai. That is cooking your meat on open fire or on in the oven. It will taste differently. So it's a very important question that we have asked. I've already asked it, and I think we should look at the taste. The agenda here, how we are going to try to make it work and give the right taste, is that we are not going to do it in the closed environment. As women, the processors, the producers are working on the outside. We want this electricity to be supplied like the firewood being supplied to dry the gari. It must still be in the open. I know that smoke does something different to the taste of the food. That's why we have got smoked garlic, smoked meat, you know. But smoke does give a little bit of different taste. So that is the next part of the project when we are now working, because now we have the device ready to be installed, to be tested, but as we are testing, we look at the taste. Thank you.
Thank you. Gundula, yes?
Yes, I would be interested because you said you want to found a startup, which is very interesting. Did you do any feasibility on the costs already?
Not yet, but that's a very interesting Oh, okay. Oh, sorry. Okay. It is important that we look at the cost for scaling up. But at the level where we are, we're just testing the first pots before scaling up. And then we will look at the cost. Thus far, on the funding of the project, we have discovered that because of the price of fuel that has gone up, we have a challenge of increased costs for the just production of the aluminium pots. But I think we can manage that. But thank you so much. I will write that, and then in the next work, we must be able to say, if we scale it up, this is how what the cost is going to be. Thank you.
Labed, we have a third question.
Yes. Yeah, thank you. Thanks a lot. Thanks you for the presentation. I would like to start with one comment. The social acceptability of such a project should be addressed, I mean, with a very high attention because of many problems that may occur afterwards. I have some experience in Senegal also that many projects failed because of the social acceptability. So, and my question, I have seen that you were using PV, but I didn't see any PV in your presentation, or I missed something, or I don't know.
Yeah, you are right. I didn't put the picture here. I have worked on this project for the past year. I've written so many reports for this project. As I expand, I end up cutting some things that may be important to others in the presentation here, but I do have a design where you have like a mini grid made of solar pieces to supply these ports with electricity. That's why I say you put it in the open. That is your structure where you are going to work must be very similar to the structure of the women that they are using in the first picture there. So for me, I think that's how you're going to do it, to supply the heating energy from the PVs, but we have made a little design. So the social part of it, as you say, it's a very difficult thing. People just decide not to accept anything that comes. People ask questions like, who's going to benefit here? Where's the money going to go? But when they go to a store and just buy some already existing stuff, they don't complain. So we hope we are not going to go through a lot of debates. We will continue with producing this, and we are not going to give it for free, so that people can go to a store who really want to buy it and use it. Think about the landline, telephone landline, and the cell phone. It was easy to replace the landline with a cell phone because the technology is there, it's quick. It's easy to go to. Thank you.
There is no other question. I have myself a question. In the project itself, there is a question there. So I give you the floor.
Okay, thank you. So if, João Cardoso from LNEG in Portugal, if I understood correctly, your system is using concentrating solar thermal for the roasting process. If the what kind of temperatures do you need for this process? Because if I understand correctly, you need temperatures below 200 degrees Celsius.
Oh yes, 200 is too high.
So 100 is okay?
What? It's simulations.
Okay, because what I want to ask you is if you have considered using other solar thermal technologies like linear concentrators, which would be cheaper to produce. Thank you.
There is another question, I think.
Yes.
Because we'll take both, because we are going on. Both and we will respond
Okay.
both. So go ahead.
Thank you for your presentation. So I have just quick question. The first one is about the Gary availability. If you have any statistic about the availability of the Gary. And the second one, how you deal with the hybridization between photovoltaics and the Gary combustion. And about the size of the pilot, how if there is any prototype that can be implemented in residential sector, because it's very the size is very big, and how we can implement it in residential sector.
Great,
yeah,
thanks.
thank you.
Okay, so you remember the question, temperature, availability of Gary, and
yeah.
size of the...
I hope I remember your question. Let me start with this one that she has just spoken. The size of the pens. We have produced this big pen so that we start with optimization of the parameters, like what is the moisture content, so that with the moisture content, the boiling point of water, for example, is 100 degrees Celsius. But then the boiling point of that solution in the Gari may be a little bit higher than 100 or a little bit lower than 100. We are looking at those parameters now. We are working on them. And thank you for that question. That is very great. And then the availability of Gari. Gari, it's a staple food, so it has to be there. So when you speak about the availability, the issue is the availability of the cassava root. In West Africa, in many of those communities where there's lots of rain, they've not yet experienced the drought that other places are experiencing, like us in the south. So it's easy to plant this. It's easy to produce the cassava root. But the big problem has been the storage. So the storage is related to the availability. So immediately we can be able to, people are already drying the Gari. But if we can scale it up, make it easy with PV, solar concentrators, then we'll be able to speak about the availability. Is it going to be easily available when it's like this? And finally, when you speak about the home, the agenda at the end is to produce a small container that we'll use in the house. As I have given an example of the cell phone, it's just like the post office. Nobody ever planned to close the post office. The email girls are the ones who close the post office. Thank you.
Thank you very much, Nancy. Thank you for this lively presentation and large success for the projects going on. Thank you. So we will go to the next project, still on the issue of clean cooking. The name of the project is Solar Induce. It will be presented by Carolina Costa, who is online right now. So Carolina, you have the floor for 20 minutes. I don't know if we hear you.
Can you hear me?
I know you are online, but...
Can you hear me?
Okay, maybe...
I have to share my screen, or are you going to present the slides? Okay,
no,
perfect, thank you.
We will present the slide, or well, we will manage the slide. You just ask for changing the slide.
Okay, thank you very much. Hello, everyone. Good morning. Sorry, I cannot be there in person, and either the project coordinator. My name is Carolina Costa. I work at Northumbria University, and I'm going to present this project, Solar Induce, on behalf of the project coordinator, that is a Spanish company. So the Solar Induce project, thank you. The Solar Induce project is a consortium of 7 partners, some of them in Spain, that is a big manufacturing company, and our partner, that is UK, a university, and other partners in Africa. One of the African partners is also a company. The main aim of the project is to develop a high-performance, cost-effective solar off-grid cooking and refrigeration solution for the African rural and remote communities. This project is based on, for the refrigeration for local products, also from the crops. This project, as it was mentioned before, is related to the March 6, that is for domestic use, clean cooking and cold chain. Next slide, please. So as I mentioned at the beginning, so this project has 7 partners. The coordinator is a big corporative company in Spain. And we have partners from Egypt, South Africa, and Nigeria. And then one of the Nigerian partners is also a small company. United Kingdom, the University of Northumbria is still in the project, but unfortunately we don't have, because of some funding, we don't have budget. Thank you. The project, as I said, there are 2 main challenges. The first one is regarding the refrigeration, and the other one is regarding the cooking. And is going to be a solar off-grid solution. So we are going to developing this domestic cooking appliance. So it's like kind of modification, and a refrigeration that is passive refrigeration system for overnight products. So the expecting results, we are going to, in principle, to have 2 pilots, one in Nigeria and that is for the cooking technology, and the other one in Egypt for the refrigeration technology. Next slide, please. So regarding the other challenge is about the solution for the cooking technology. So in this case, the project is working in a already, I would say, a well-known solution, but the innovation here is to reduce the cost and to increase the efficiency of the product. So, and also one of the challenge here is to design a cookware solution that increase the efficiency, reducing the thermal losses of the cookware when we are doing those, when we are using those appliances. Next one, please. So when we are talking about what we have done in the project, I afraid that the project have kind of big delay, mainly for the funding of some of the partners. So as I mentioned before, we as university in UK, we don't get any funding, so we are collaborating with the training of some of the Nigerian, in this case, South African partners. So the knowledge about the preparation of some of the product that we are going to use for the refrigeration was done here in UK. So in this slide, you can see that a team from South Africa visited us recently to be training in the preparation of the mucilage. That is a I would say a material that we are going to use as a passive in the passive refrigeration. So it's going to storage the heat, or I would say the cold in this case, to release at night for the passive refrigeration. So in that regard, the partner in South Africa, they have been working in the preparation of the mucilage they were working with some decanat nut and those kind of crop, but they have facing some issue in the in finding the raw material, because they are mainly in Nigeria and they are in South Africa, but they are still working on that in the preparation of the mucilage and the hydrogel, for the hydrogel. So next slide, please. So regarding the refrigeration system, this, as I said, the refrigeration system part is the design of the system that they are going to try to test new refrigerant in a well-known system, and using the mucilage, preparing hydrogel for the passive refrigeration. Unfortunately, the part of the design of the refrigeration system with new refrigerants is kind of is not yet started because of that partner that is mainly this work package is not having any funding at the time being. So this is a big issue that we are facing in the project. So we are saying that for the main two challenge, we have the refrigeration, we have the cooking. In the refrigeration, the part of the development of the material is going. We are working with the South African partner in the preparation of the hydrogel from the mucilage, but the part of the design for the prototype, this part has kind of important delay. Next one, please. So regarding the cooking part, this there is no any issue in the design of the solution for the cooking. So the partner from Spain, they are working in new materials for reduce the cost of the cooktop, and they are also working and testing part of the off-grid solution, because in general this kind of solution they work with AC current, and in this term they are going to try to do some modification to reduce the cost and integrate with that off-grid solution. So the main advance here in the project is that they have been testing new plastic material that are going to be using in the cooktop instead of the traditional glass. And those plastic, they are developed right now, the testing for the thermoplastic instead of the how it's going to integrate the other component in the plastic with the touch control and those kind of things for the cooking system. Okay, so here in the picture you see the two kinds of the thermoplastic and they are currently tested for the induction cooking. Sorry. Next one, please. So also in Spain, the partner in Spain, they are already testing some of the modification of the design that they propose for this cooking solution. So I didn't mention, but the cooking solution is going to be in induction, no in radiant solution. Well, is in general induction is higher efficiency, and for that reason, it's important to have also the development of the cookware, I would say, adapters, no? That is going to be developed in part of from the Nigeria partner in this case. So regarding the progress in the project in the cooking solution, there is not any delay. The partners are working following the schedule, the original schedule. So they have already developed doing the simulation of the cooking with the plastic material, trying to see if the magnetic fields are passing there is any issue with that, or they have increased the efficiency. They have redesigned for one how you say that, focal or place the solution. And in this regard, the project is going in the direction accordingly the objectives. Next slide, please. So regarding the problems, as I mentioned before, there are some issues. We have important delay in the starting of the project. This was the first one because one of the agency that is funding the coordinator was having an important delay. So initially the project was, the initial time, the starting time of the kickoff of the project was delayed like more than 6 months. So that's one thing. So this is because of the coordinator funder. Then after the kickoff, well, before that, we already know that UK will not receive any of the funding. So some of the tasks that the original were for UK could not be developed. So we are trying to collaborate, but there are some limitations, obviously. And another important issue in the project that is still not resolved is the one of the partner in EGIC, they don't have the funding. So still there are some administrative issue with the funding agency. Regarding the technical part, we will say, as I say, the technical part, some of the work package are not yet started due to the funding issues. The parts that are running well are the development of the cooking solution from the Spanish partner, and the development of the hydrogel from the mucilage from the South African partner. Those two are going well. As I say, the Spanish partner for the cooking solution for the solar off-grid is testing right now material, is testing the design. So that part, and we don't have still data about how more efficient is the system, but we are going to have that in a couple of months. Regarding the hydrogel from the mucilage, partner from South Africa working with us are preparing the material, and now they are going to do the characterization. So that was part of the training that they received here in UK, how we are going to characterize those hydrogel to test in a refrigeration system for passive storage. Next one, please. So, as I said, mainly due to the delays in the starting and in the funding part, we are going to request for an extension. So we are expecting to have the result of the project in 2025 instead of next year, but we are confident that after those administrative issues are going to resolve, we are going to have in a good position for complete the project accordingly the objective. Also, based on the project, we are happy that there has been some new based on the networking and the collaboration. So the partner from Spain, they were in Pretoria, sorry, and they have kind of developed some new collaboration there. And based on that, we have presented 2 different projects in working with sub-Saharan countries, so Kenya and Angola, and we were also working on that. So, but well, it's still we are presented, so that's not. But we are working and develop new collaboration based on the LEAP project. Next one, please. As I say, so we are having we have developed some new collaboration with the different partners. We have meeting new partners, and our intention is continue to working in clean cooking from different areas. So we working in the thermal efficiency, reduce losses, cookware, induction, radiant cooking. So we are having strong collaboration in that way, and we are planning to continue applying for funding in that area. Also, we are planning for next year to apply for another European European project. So we are happy to continue working in that. Next slide, please. So, well, the expected outcome, as I have been mentioning during the presentation, so once that everything is running and the companies are the prototypes, so obviously the creation of employment and those things. Right now, the main thing is to have those partners with the funding to real commit to the objective and create and develop the pilots testing and then running the project. So I am afraid that I cannot present more technical things because there are huge delays in the project. So, but we are confident that once that those funding issues are solved, we are going to continue with the project and have the outcome that we were expected. Next one, please. I think this is the last one. Well, is still what are the contributions? So I will not stop here because those are like part of the presentation. As I say, we would like to present more the technical part here in this meeting, but unfortunately there are some delays. However, as I said, cooking is running well. Apart from there are some delays in the cookware design due to administrative issues. Funding count as is, and refrigeration is running one part of the refrigeration and the other part is not. So the main concern is in general in the project, if that funding part is not running, is not solved, it will be that the 2 main challenges are going to be partially solved. In regard of the cooking is working well, but the cookware adapter is not. In the refrigeration part, the preparation of the hydrogel is running well, the part of the integration of the system is not running. So, I mean, the project is running, but we have some issues. And I think this is the last slide, but next one, please. So that's it. Thank you very much. I will be happy to answer any question.
Thank you, Carolina, for this presentation. I would like to, before taking question, and I will take question, precise that it's one project coordinated by a company, a Spanish company, so it's not often the case. It's very interesting. And the other issue is what has been raised by Carolina, is that for some projects we have administrative issues due to the time to make contracts between the funding agency and the laboratory in one country, and so there is an impact on all the project, and so this happened in 2 or 3 projects we had in this first call. Of course, we are well aware, and we try to accelerate, but of course it's mainly national issues to be solved. But I am quite confident in the fact that it will be solved soon, since the funding agency concerned is well aware and is making all could be done. It's not only the responsibility of the funding agency, but the administration of the country also. Okay, so I will take questions. Yes, Johannes, if I see well.
So thank you very much for the interesting presentation. I think it's, I would like to know if you already have an idea of the power rate for the induction system, and if you have estimations for the cost of this system, of this induction system. And as a second question, I would like to know if you could explain a little bit your motivation for using solar-powered absorption systems for refrigeration instead of PV and heat pumps, for example. Thank you.
Okay, so about the first question about the induction cooking system, I mean, traditional, the induction cooking is around 2 kilowatts. Can you hear me properly? Sorry, I just not why. Yes, can you hear me? Yes? Yes. Okay, sorry. So about traditional, or common induction cooking, they have about 2 kilowatts, 1.6 kilowatts. The aim in this one is to reduce a slightly, I think that I'm not quite sure if I'm going to say wrong, because but I think they are thinking lower than 1.5 kilowatts. So it's going to be because of it's going to be solar power, so we have to reduce that power consumption there. Yes, that's it. About the cost, we have initially when we present the project, we evaluate the market cost. I cannot give you a figure right now about the cost, but the company is working, because one of the main components that is increasing the cost of those systems is the glass. So once that the glass is going to be replaced for that plastic material, has to be a huge impact in the final cost of the product. But I cannot give you a exact figure right now, so that's more I mean, the industrial partner has to talk about it. But yes, it will have an important reduction of the costs. And also they are doing some other modification in the system about those electronic touch and those electronic control, that they are going to reduce significantly the price of the product at the end. But I cannot give you, unfortunately, a figure right now. About the absorption system for the refrigeration, the initial idea was to use other kind of system, but after, I would say, preliminary evaluation, we thought that the absorption system is going to give more advantage in terms of the cost instead of the heat pump or traditional system.
Thank you. Carolina, is there other question? Yes, Gundula?
Thank you, Carolina, for the nice presentation. It seems that you have a very good cooperation in your consortium. So for me, it was not clear because you explained that the UK has no funding and that there are limitations. So will you change now the objectives, or what impact has it on your results?
Yes, that's a good question. Thank you very much. As I say, I mean, in the original plan, UK have playing an important role in the design of the cookware adapter and in the design of the refrigeration. So that is going to have an impact in the project. Maybe I don't know if it mainly in the final design of the refrigeration system. In the adapter, this part now is totally leading by the Nigerian partner, and that part is there are another kind of issues there, but yes, it will have definitely an impact. We are trying to minimize that, and we are trying to continue the collaboration and providing. I mean, we cannot, we don't have the resources to do some experimental tests or whatever, but we are trying to transfer some knowledge from us to them. We have been done that from the preparation of the hydrogel. Unfortunately, not yet. We have started to do that in the refrigeration part, but this know-how. This is, I mean, in that sense, the know-how is also in the GIG partner. So it's kind of just kind of support. It's not really, but yes, it will have definitely an impact. We are trying to minimizing that. Because originally the project was the coordinator was, we were the coordinator, so we did all we prepared the consortium, we joined the partners and so on, and well, it was really a no good news for us that we will not have the budget, but we are still interested in this area, and we are trying to collaborate with them. We are providing all the support that we can, and we are happy to continue with the project, even if we are just, like knowledge transfer, participate in the meeting, trying to, if there is an issue, to solve. But it will have an impact mainly in the refrigeration part, yes.
Yes, maybe I will precise, Carolina, about what you said, because there is an issue, an administrative issue about some funding right now in the existing consortium of the project. But there was also at the beginning an issue because UK, when we launched the first call in LIPRI, UK was in the funding agencies when we launched the call. But when we received the project, due to financial restrictions in the public aid to development in UK withdrew from the funding of the projects. So we had to manage some projects. Some British partners stay on the consortium without being funding. Other withdraws, and we had to adapt the project. So Solar Indus has this double issue of UK withdraw from the funding, and right now some problem of contracting issue. But I think we could solve, and as Carolina said, we could continue this project. Other question? Yeah. Yes.
Hello, Bernardo, I'm the project officer for LIPRE. So, no, just one small question regarding the non-delivery of the, if I remember correctly, the thermal. It's thermal storage. No, wait, it's the cooling unit, if I remember correctly, by the industrial partner. Do you have a timeline for that?
Sorry, Bernardo, I don't hear very well.
You don't. Can you hear me now?
Okay, better.
Thank you. I'm sorry for that. No, my question is, what is your estimation for when you will be able to deliver the critical piece of equipment that you're missing? Because, I mean, for the moment you are looking to 2025 to close the activities of the project, but does that timeline take into account that delay? And how critical is it for the delivery of the final product?
Okay, as I said before, for the cooking part, we are running well. For the refrigeration is the delay that we have. We are just, the coordinator have requested an extension because our project was not, was 18 months, if I'm not wrong. So I think that once that we get the extension, we are planning to continue with that, but we need the extension for the project, definitely.
Yes, maybe Bernardo to try to also to respond. Hopefully this is the first call, so the projects are not supposed to at the beginning to go on at 2025. So the issue right now is to implement some amendment in order to have more time for this project. Of course, it's complicated because it involves several funding agencies, but we are going on to do that, and I think it could be finalized soon, I hope.
Yeah. So unfortunately, I cannot give kind of a exact date, but as I say, we are the partners are still negotiating with the agency, the funding agency, and once that is solved, if we get the extension, so we are going to work towards the objective, initial objective. Yeah.
Thank you. Other last question? If not, sorry. Go ahead.
Thank you. Just a technical question, which is about your project is on cooking, I would say, and you mentioned the extraction of, sorry for the French pronunciation, of mucilage and hydrogel. Can you explain a bit how did you get this, and what is the economic impact of this extraction of mucilage and hydrogel on your project? Thank you.
Okay, well, I am not the technical expert in the part of the mucilage, but I will try to give just a brief outline. So the impact first is that we are going to use natural products that are waste in those in Nigeria and South Africa. I think that there is one of our partners there, Raymond. He can also. Raymond, are you there? Maybe you want to answer that question, or you want me to answer? I saw you.
Well, last question.
No, sorry, it's because we have a partner, our partner Raymond is there and he's working in the mucilage.
Sorry, I didn't understand. Okay.
Thanks.
I don't know if you want to answer or I continue with my brief. So.
Thanks, Karen. I'll try to assist. Yeah, I'm Raymond Chazwa. I'm one of the project partners from Waterstool University. What we have done from the South African point of view is that we have identified an agricultural waste that was normally being incinerated, and burned and dumped into the environment, and its consequences. So we've converted that agricultural waste into hydrogel because it contains a high content of cellulose. So I've managed to extract the cellulose from the hydrogel through a simple chemical process, and then now we are busy with the characterization of the hydrogel. I don't know if I've answered that part. Yeah. Okay, thanks.
Okay, thank you very much. I think we have to close because we are out of time right now. We have now another project to be presented, two other projects to be presented in the session on clean cooking. The first one before the coffee break and the second one after the coffee break. So I will call Johannes for the SoCoNext Gen project. Johannes, so you will present a project coordinated by Germany. You have the floor for 20 minutes. Thank you.
So only thing you need to do is share the screen. It's not. It is sharing. Okay, perfect. It's not the Zoom. Sorry? It's sharing, right? Yeah, but it's not in presenter mode. It's not going into presenter mode. No. Where's this one? No, that's the editor. What are you looking for? This one. So when I press presenter mode, it doesn't go into presenter mode. It just stays it as. That would be to stop sharing.
Stop sharing. Yeah, you can stop first.
Okay. It says block, and here says allow, but it's so when I press here, I selected my presentation.
Yes.
Which is the PowerPoint second.
This one?
Yeah.
Okay.
Unless there's also another one here. Didn't I try that one? Maybe this one? Try that one, maybe that one works then. Yes. That one. Yeah. IT, sorry, it's still not doing it. Excuse me? Sorry, it's not doing it. We try again.
Yeah, let's try it again.
Let me try that now. Okay, can you? Yeah. Yes. Just.
You can read through as well. You can use it.
Yeah, it's fine. It's fine. Sorry about that. Okay then. So ladies and gents, I'm pleased to be here today in person in Kigali, Rwanda, to present the progress of Project SOCO Next Gen. My name is Johannes Sattler. And next slide, please. The project consortium consists of 7 partners, 3 from Germany. So I'm from the FH Aachen University of Applied Sciences. We are the project coordinator. And then from Germany, we also have the engineering bureau eBoy and the non-profit company Low-Tech GmbH. Then from Algeria, we have the Renewable Energies Development Center. From Portugal, the University of Évora. And from Morocco, the University Mohammed Premier Oujda. And finally, from Tunisia, the University of Tunis El Manar. Now, in the last days here at the LEAP-RE Stakeholder Forum, the importance of clean cooking has been highlighted by several speakers. This is because the traditional way of cooking is still widespread in Africa, especially the use of firewood is causing huge issues in several ways. For example, one severe way, health issues, several health issues which have been identified due to the inhalation of the harmful smoke, just one of the problems. And also there are issues with the problems to the environment when cutting down trees. One has deforestation, and as a consequence of deforestation, also soil erosion, etc. So in our project SoCoNextGen, we are tackling some of these issues by developing and building and testing 4 different solar cooker technologies, which I'll be presenting in more detail in a moment. And in our project, we are addressing the MAR 6 innovative solutions for priority domestic uses, i.e. clean cooking. So, regarding the scientific and technical objectives, in particular, our focus is on the design, the construction, experimental testing, and analysis of 4 different newly developed and efficient solar cookers, which can be temperature controlled, and they also feature either a thermal energy sun storage or a battery, or even both. I will show the details later. So our application for the future is domestic households, and also even commercial environments, such in the future could be kitchens from school, as an example. But there's barriers to be removed. It's not that simple, just say we're going to build solar cookers, everybody's going to use them. We also have to have the acceptance by the end users of these solar cookers. So it involves education, but also understanding the needs of the users, like what we heard today in the morning. People are used to having also the flavor of smoke in the food. So one has to address all that. Then the other thing is, a solar cooker doesn't come for free, as no technology comes for free. So there have to be funding options or some form of financing for the especially poorer population, so they can actually invest in a solar cooker and profit from such a technology. Regarding intended results, so with these solar cookers we are developing, we want to be able to successfully prepare the traditional dishes which are cooked in the target countries. And very important is also having the storage units. We want to have flexibility for cooking, meaning also being able to cook in the nights or in the mornings when there's no sunlight available. We are also, our partners from North Africa are doing a potential study which addresses several things. I'll give an example later. And very important, because we are testing for different cookers in different countries, we need to be able to compare them. And for that, we need to have a standard testing procedure so that we can have a proper scientific comparison to see how they compare to each other. But then, the last very important point is, of course, to also have talks with at least one company regarding the future distribution and also the production and distribution of such cookers in Africa. Next slide, please. Right, so I'm now going to give some details about the different cookers. So here in this image, you see 2 of our cooker designs. They're called 1A and 1B in this case because they're very similar in design. So if you look at the left image, you have a cross-section view through a kitchen and also cross-section through the cooking unit. So what you can see, I don't have a laser pointer or anything, but there's cooking pots, and in red arrows it's indicated an oil circuit. So we are heating the cooking pots with thermal oil or any other oil which can be used. And we also have the sun storage, which can be charged and discharged via this oil circuit. The heating for this cooker 1A is done with PV modules, which can be, for example, placed on a roof. And then we use an electric heater for heating the oil. Also, we have a small electrical battery storage, which can then provide, for example, electricity to small electrical appliances, e.g., lighting. In the figure on the right is very similar, the solar cooker in design, with the difference that here we are not using photovoltaics, we are using a flat plate solar collector with a front and a side mirror to increase the solar radiance in order to be able to raise the temperature of the oil. The desired temperature which we want to achieve heating the oil is 250 degrees Celsius for cooker 1A and 230 to 250 degrees Celsius for cooker 1B. So the cooker on the left shall be sent to our partner in Tunisia. The cooker on the right shall be sent to our partner in Algeria. Here I want to show some CAD drawings of the cooker design. Sorry, the next slide, please. On the bottom left side, you can see that the cooking unit is placed on a standard Euro pallet to make it easy to ship these units. And you can see on the top on the work unit is that we have 3 pans, so 1 frying pan, which is rectangular, and 2 cooking pots. And in the second image from the left, you can see the inside as piping and also a large storage unit, the large container which contains the sand storage. On the right, you can see some pictures of the development or the construction process. Here, the cooker is turned upside down just to show you the piping connected to the pots and just what it looks like. On the top, you can see a photo of the frying pan and a cooking pot. Next slide, please. So this is the third solar cooker, which we call solar cooker 2. This is a hybrid cooker. It's basically combining photovoltaics and flat plate solar collector with additional mirrors. Here, the difference to the first 2 cookers is that we do not have a thermal energy sun storage. Rather, we have a small electrical battery storage, which has a size of up to 4 kilowatt hours. We are still discussing which size to take. And so the idea here for this cooker is to use the thermal collector for cooking during the day, and then simultaneously we would charge the battery storage during the day using the PV modules to then be able to also cook in the absence of solar irradiance. This particular cooker shall be shipped to our partner in Portugal for testing. Next slide, please. So here's just some photos from the current construction. So on the left side, you can see there's 2 cooking units, 2 cooking pots. We do not have here we do not have a frying pan, so here we just have 2 pots. On the right side, you can see the flat plate collector. Here it's being modified. We have an additional frame on top of it where a second glass pane will be installed in order to reduce the thermal energy losses such that the temperature from the oil can be raised to the desired temperature of around 230 to 250 degrees Celsius. Next slide, please. Right, and now this is the last solar cooker we are developing, solar cooker 3. This is a design entirely done by our partner in Morocco. So this is a complete electrical cooking unit. So it uses PV panels to charge a battery storage. This is a larger storage compared to the previous hybrid cooker. And so this concept foresees that the cooking unit has 2 electrical resistant cooking tops, and one of these cooking tops is directly fed with electricity from the PV panels. It's directly powered from them, and the other one is powered via the battery for cooking. Next slide, please. So here I'm showing some photographs of the laboratory of our Moroccan partner. If you look at the bottom right picture, here you can see what the cooking unit looks like. This is a DC type cooker. It's not using AC, it's using DC electricity, DC current. And here you can see in the laboratory some tests being done by cooking something. On the picture on the bottom left, you can see the entire setup. So there's some electrical control units which need to be used for the charging and discharging of the batteries. Here you can also see the batteries on the left side, which are used for the tests. There's various measurement equipment to validate the cooker and to see how its performance is. There's also a weather station, of course. Yeah, and on the image, on the photo on the top right, you can see the PV panels used for the tests on the roof of our partner Morocco. Next, please. Can you, IT, can you please proceed with the next? Oh, I'm sorry. I'm looking. Sorry, can you go back? I'm sorry. I'm sorry. It's my fault. Yeah. Sorry. So the prototype is being tested extensively and is being improved by our partner. For example, looking at improvements regarding thermal losses. So they are improving the thermal insulation, for example, at the moment. So there's important work being done by our partner in Morocco. He's the most advanced with the cooker design from all of us, and he's very, very busy networking and finding potential users for this Solar Cooker 3 who shall experiment with this cooker. So for example, there's the Kunuz Autism Center in Morocco, which has expressed interest in installing the cooker at their autism center. Then they're also in discussion with the Tafakalt forest area, which is very close to Oujda, where the university is in Morocco. It's like a remote settlement where people are interested in using it. But also very recently, they were contacted by an association because of the recent terrible earthquake in Morocco near Marrakesh. So the people are suffering there, and they've been asked if they could provide the Solar Cooker 3 as a relief to them. So discussions are ongoing. And finally, regarding the slide, so last year at the Stakeholder Forum, there was a question from a gentleman regarding why we are not involving countries from the sub-Saharan region. It was a very good point. And I'm pleased to say this time that our Moroccan partner has contacted, or has been contacted, or is in discussion with the University of Tis from Senegal and local residents in Senegal regarding testing the cooker. Next slide, please. So, as I mentioned earlier, there's also a potential study being done focusing on the countries Morocco, Algeria, and Tunisia. This is a potential study which is in progress, and it will go on until 3/4 through the project. The partners will address several important questions, such as which type of cooker is best suitable, and certain boundary conditions, where the people live who are in need of these cookers. So here, what you can see here is regarding using solar thermal cookers, good values of solar irradiance is important, and Morocco, Tunisia, and Algeria, our partners, they have excellent solar irradiance values. So throughout the country, basically, the solar cookers will work very well, of course. Next slide, please. What all partners are also busy with is developing simulation models of each cooker, so that when they're testing the different cookers in their countries, they can also run simulations to make predictions and to see how the performance is. Next, please. So regarding the progress in comparison with the state of the art, so typically solar cookers are outdoor cookers without thermal or electric storage. In our case, we want to have indoor cooking possibility with storage to allow flexibility and comfort for all the users. We are also developing this thermal sun storage, which we believe is a new development, and also the solar cooker operating with thermal oil and photovoltaics is a new development. Next, please. So in the project, we are aiming at developing towards TRL 6 and 7 with our cookers. Next, please. But the thing is, during the development and construction time, we have encountered also problems. So, for example, the development phase of the cookers 1A, 1B, and 2 which were done from the German side mainly, regarding CAD drawings, took several months longer. Many optimizations had been done. And also we have found out now that the construction time is taking longer than anticipated because of issues like having to test materials and then replace them, test again, replace. And it's like an ongoing process just to find the best solution. But once we are there, then it should hopefully be going great. So next, please. Regarding new developments, no, sorry, go back, please. Regarding new developments of software, our partners in Tunisia and Morocco are co-developing a software for monitoring measurement data produced by the solar cooker tests, and also partners from abroad will then be able to look at the live tests if we want to. Next, please. So regarding follow-up work and youth pathways to explore, so towards the end of the project, we need to have evaluated the solar cookers and then see, did we achieve our intended results, which I presented on one of the first slides. So that will allow us to then do the decision-making regarding future pathways for the developed solar cookers. We also want to make a ranking of the cookers to see like which one performs best. So at the end of the project, we will then know how the results are and can then evaluate opportunities for a follow-up project. Next, please. Several collaborations are in the making. So, for example, the Moroccan partner is talking to decision makers and elected officials in Morocco regarding the Solar Cooker 3. And very interestingly, a company from Paris is also in close discussion with our Moroccan partner regarding a future marketing of Solar Cooker 3 after the project, so after 2025. And we're very pleased to hear that. Next, please. I'm almost finished. So regarding the expected outcomes, in case of success of the project 2030, there are many things like long-term savings in fossil fuel, relief to the people who no longer need to inhale smoke, reduction in time and effort for women and children for collecting firewood, amongst many other positive outcomes we are expecting. Next, please. So regarding the contribution of the project to AU and EU R&D partnerships, so we are hoping, of course, that in the long term there will be a creation of jobs, there will be education for the people, knowledge transfer, which is very important, and of course capacity building, especially if cookers are being built in, for example, Morocco or other countries, so that local capacity building takes place, not just abroad. Yes, and basically, also very important, I want to highlight, we are planning 2 dissemination workshops, one in Algeria and one in Morocco, where NGOs, journalists, politicians, and others, decision makers are also going to be invited, so that we can spread word and demonstrate the technologies, to basically, spread the word of solar cookers. Yes, and so I've already had loads of time for networking here at the Stakeholder Forum. It's been very interesting so far. Be nice to network more in the next days. And with that, I'd like to conclude just showing the partner logos. And on the last page, I would like, next slide, please. I would just like to thank all the involved funding bodies and funding agencies for kindly supporting our project. So thank you very much, and with that I'm concluding the presentation, and I'd be happy to answer your questions. Thank you very much.
Thank you. Take that hat also. Hi. Thank you, Janice. Thank you very much. We'll take the question. I have a question myself. If you looking at that, you are a target of GRL 7, as far as I understood, for the solution using thermal oil. The application will be, from my point of view, rather in collective cooking kitchen rather than individual one, since thermal or synthetic oil is not maybe so easy to use. Could you confirm what will be the target market?
For the solar cookers?
For the solar cooker using thermal oil,
yes.
Generated from the solar thermal.
Yeah, so basically households are, the domestic use households are our main aim right now. So we are going to be inviting test cookers, from the public, so to say, so that they can give their impression of the cooking quality with these cookers, to give feedback, which is highly important, because this is, the feedback from the actual users is something we need to evaluate in our potential study in order to rate the solar cookers. In the long term, not within this project, we're also looking at scale up. Looking at schools would be something perhaps in a follow-up project, to have a large kitchen, so that children in school can be provided with good food, with sustainable cooking.
Thank you. Question? Well, there is a lot of questions. So I will begin there and there. We have 4 questions.
Thank you for the presentation. I want just to ask you if you are all contributing for the development of one prototype, or if each team is developing its own.
So as I mentioned before, the Solar Cooker 3 is entirely developed by our Moroccan partner. The Solar Cooker 1A and 1B is designed by the German partners. But what I forgot to mention, sorry, the Solar Cooker 2, which is the hybrid cooker working with flat plate collector and photovoltaics. This is actually a co-development of one of the German partners and our partner in Morocco, because it needs also electronics, and these electronics are the ones also used for Solar Cooker 3, but there's certain adaptations as far as I'm concerned, so that it works with Solar Cooker 2 as well. Not every partner is doing the design, but they will be doing the extensive testing. And what I would also like to highlight, what I didn't mention because of time constraints, is that we are also going to do a commissioning workshop in Tunisia, where we are inviting all the partners to participate. So we will look in detail at all the construction details to explain in detail how it works and what can be done in case there's any problems, how to operate the storage charging and discharging and all these things. So they will be involved in detail. And of course, we are involving our partners in the construction process, updating them with the details, so that they're not left out in the blue.
So thank you for the explanations. As we saw, you are aiming for TRL 6 and 7. It's out of lab scale. And I was wondering, because I got the impression your combinations of different technologies and also storages, also the size of the storage is quite big, no? So it will be quite costly for the people in rural area where you're targeting. So what are your expectations on the market? So who is going to provide these cookers for the communities? Because I assume that they will not be able to afford.
Yes, this is what I was addressing earlier on in the presentation. Is we need to very closely address the financing options for people who are already poor using wood and don't have many means. So this is why there's talks with, for example, on the Moroccan side with the local politicians and decision makers, but also NGOs can be involved to get funding so that these cookers can be installed. So there's going to be need for external help because no technology comes for free. This is just how it is, I'm afraid. But we are, of course, aware that funding needs to be available for the people, and we are working on that to basically be able to say like this, that, and that. These are the possibilities for poorer people to actually be able to finance such a solar cooker.
Thank you. We have 2 questions after we have to close for the coffee break.
Okay, so yeah, well, thanks a lot for your good presentation. As far as I understood, the originality of this project is the fact that it uses a thermodynamic loop with thermal oil circulating in all
for 3 cookers, yes.
The solar cookers. So I have a simple question: how you modulate heat when it comes to passive solar?
We have valves where we can vary the natural circulation of the oil and can therefore control the thermal power for cooking.
Yes, when it comes to cooking, temperature is very important. And
it is,
before
yes.
you mentioned because
yes.
You cannot cook everything at the same temperature.
We have valves for the different, like there's a valve for each, for the frying pan or for the cooking pots, so they can all be controlled individually.
Okay.
So we are very, very aware of the need for the users, to have the comfort everybody would like to have. It's very important.
When it's with the electrical part, you have no problems with that. I was referring to the passive collectors.
Yes.
And the second question maybe is related to costs.
Yes.
And also to social acceptability, because it varies from a country to another.
Yes.
Algeria, as far as I know, I'm from Algeria. The availability of natural gas is
it's cheap, then, isn't it?
Cheaper, and so on and so on.
Yes.
How competitive is this kind of solution? I mean, I have seen that you are making some simulation models, and have you an evaluation of costs on these things included?
We have already discussed, the availability of cheap fossil fuels in our target countries, and the competition we have with that. This is something we are addressing. And regarding costs, we have already done some current cost estimations of the not finished systems. And as an example, the Solar Cooker 3, we are looking at costs of currently around 1,400 euros, with the aim to reduce it even more. But you've got to keep in mind it also has batteries, right? So it gives a lot of flexibility for cooking. So without batteries, it would be cheaper. Right, and what you also got to see is, what I didn't mention, is that the cookers, like the cooker 1A and 1B, we are designing it, and like in our view, up to, it should be provide food for up to around 14 people per cooking. So we're also looking at, if you provide food for a larger group on a daily basis, it makes the specific costs, investment costs, cheaper, right? So there's various angles we are taking at looking at like which cooker might be better suited for certain groups of potential users.
Okay.
Yeah, we are very well aware of the questions you've raised, and yes, we are working on that.
Thank you.
Okay.
The last question.
Yes.
Thank you for
Hello.
the presentation. Glad to see a DC cooker fitted directly by PV.
Yes.
To avoid inverters and losses made by inverters,
Yeah,
etc.
shall make it cheaper.
Yeah. Okay,
Yes.
so I have 3 quick questions.
Yes.
The first one about the maximum temperature achieved by the PV process and the thermal process and the both process, perhaps maximum or minimum, just to have an idea how, in the case of no sunny days, what is the temperature achieved, the maximum temperature achieved?
Regarding the DC design, or?
Yeah.
Well, yeah. Can I just answer that question before you go on with the other ones? With DC cookers, as far as I'm aware, other designs which exist are not able to have elevated temperatures, but our Moroccan partner he is able to, achieve high temperatures. We're looking at ranges of 230 to 250 degrees Celsius for our cookers, for all of them. So that we have ability to cook anything, fry anything, prepare any food which is commonly, prepared in the target countries.
Just one question, because I see that PV, that the battery feed the cooker process. Why do you not, the PV cannot directly feed the...
It is. Yeah. So the Moroccan partner, one cooking pot is fed directly by PV, and the other one is directly fed by discharging the battery. So it's using both.
Okay. And the last one, about the security. Security,
yes.
If it is evaluated in this process.
Yes, highly important to us. We want to have very reliable and secure cookers, which reduce the risk of, for example, if you have like a traditional stove near the floor and children could touch it and get burns. We don't want that, of course. So these units, they're a bit higher up, and also the Moroccan partners unit can be placed higher up, so children cannot access it. And of course, regarding electrical security, everything will be like the control blocks in a housing, of course, to secure it from any external influences. So yes, highly important. Nobody wants a fire, and also the batteries are. Those which are not, we're not using lithium batteries because that's too dangerous, of course, right? Yeah.
Sorry, we have a last question online because we will not penalize those who are online. So Carolina Costa, who presented the previous project, you have the floor. You have open your microphone.
Okay, thank you. Just I have 2 questions. The first question is about the temperature, because I know that some of you say that you need the temperature, but some of the studies say that you need the heat. So can you evaluate or have you evaluated to reduce the temperature of the oil?
Yeah, as I was mentioning earlier, we are using valves to control the heat flow, and we should easily be able to, to adjust temperatures with that.
Yes, no, but I mean that you are talking that you are working between 200 to 250 degrees.
No, these are the maximum temperatures we are achieving. So the maximum temperatures we are looking at is 230 to 250 degrees Celsius to, allow cooking of any form of traditional meal, including frying.
Okay, so regarding the thermal energy storage, you are talking that you are using sun. So have you evaluated to use latent heat instead of sensible heat in order to reduce the size of the storage and maybe control better the temperature of the storage?
Well, the thing is using sand. Sand is super cheap, available easily, and although the storage unit is large in size, it doesn't take away any space because it's placed underneath the cooking area, and since one is standing cooking anyways, it doesn't take away any space at all, this is a very safe material to use. There are of course other options. One can use also fluid for storage. We chose to go for sand in this project. And of course, we'll be evaluating the performance of the sun storage within the project.
Okay, thank you.
Thanks. I hope I answered your questions.
Thank you very much all for the questions. Thank you, Johannes. So we will break for coffee right now. We are slight in delay, so I ask you to resume here at 11:10, 10 minutes after 11. So you have between 15 and 20 minutes for coffee break. Thank you. Okay, thank you. Being back. So we have still one project from the session on clean cooking and biomass. And after we will have 3 projects on productive use of renewable energy before the lunch. So the project on clean cooking and biomass is Pyro Biofuel. It is coordinated by Fatma Ashour from Egypt. I am not sure she's online. We don't see her connected right now, and unless there is somebody on site representing her, but I don't see that. Online, In case, Marie-Laure, you don't have any, you don't see any?
No, I think I don't see anyone from biofuel online.
Okay. So what I will propose is that we will split to the productive use session, and if Fatma Ashour connect, we will insert her presentation later. Okay, so the first project of the session on productive use is MG Farm, and I think it's Austin Bellamy on site. I haven't seen him, and online either. I look at yes.
The colleague has just left the room.
Maybe they thought that there was pure biofuel before, and they are on the in the coffee. But from MG Farm, they, okay. So we sorry, since the pure biofuel is not present right now, I will ask you to present right now. So I let yourself present yourself, and you have 20 minutes presentation.
Thank you. Good morning, everyone. I'm Lotfi Bagli from University of Lorraine. Could you please put the slides of MG Farm on the screen? Okay, they are coming. Filling the gap. Okay, I will stand here. I will appear taller. So MG Farm stands for microgrid for farms, but more it's like smart microgrids as a solution for agriculture farm electrification. Next slide. I can put it? No, thanks. So I am Lotfi Bagli. I am coordinate this project along with my colleague from University of Lorraine, Serge Federici. We are from two labs, one on green and the other one is LEMTA. You see our logos here. Our other partners are University of Tlemcen, CDER UDES, Unité for Solar Energy, renewable energy, but mainly solar energy in Algeria. And we have also an SME in France called EU Corp. We have three partners from Germany, two of them from TU Berlin, one in social science, and the other one on batteries. And we have a small SME, Microenergy International. And we have three partners from Morocco, the École Nationale des Sciences Appliquées d'Oujda, ENSAO, the Green Energy Park, and International University of Rabat. So the aim of our project is the development of microgrid based on renewable energy system to support certain sustainable development of energy, water, and agricultural sectors. So based on the load profile and storage strategies of modern and sustainable agricultural practice, the system serves typical requirements such as pumping, irrigation, and cooling. So the relevance of our project versus the multi-annual roadmaps is the installed digitized renewable energy microgrids and smart storage system will have a measurable impact on MAR1 by contributing to the development of database research and educational framework for the integration of smart grids. So this is MAR4, excuse me, in the MENA region. And we will have also experimental results, and we will enhance local capacities on how the digitalized renewable energy microgrids and smart storage system will enable the connected farms to increase their production, to save water and energy, and this is contributing this way to MAR 5. Next slide, please. So the scientific and the technical objectives, we are designing and studying up to a tier 6 digitized microgrid with a smart storage solution on demonstration farms in Algeria and Morocco, and to equip them with remote data monitoring and infrastructure. We are dealing with plug-and-play concept microgrids that can be connected or disconnected without the intervention of a human. So it is an automatic system in grid forming or grid following, so the inverter will change its behavior. And enhance partner skills around digitized renewable energy microgrids and smart storage system. We have 3 PhDs in co-supervising between North and South countries. Monitor and test water, energy consumption levels, and agricultural production on the demonstration farms. Next slide. Develop a comprehensive data collection and analysis framework, so DCAF. Conduct baseline study on agricultural practice and socio-economic environment of the participating farms. So you see here, we're working on 2 aspects, scientific aspects and also socio-economic aspects with our partners from Germany. Identify and examine best agriculture practice for climate mitigation and adaptation in the region using specific methods in the DCAF. Conduct throughout assessment of the agricultural activities and practices of the pilot farms, including their energy and water consumption, and utilize the results to model optimized energy, water, and material flow within the farms. Model the currents and the optimized agriculture processes on the farms using quantitative computers models. Next slide, please. Research new businesses opportunity arising from the use of digitalized microgrids with the smart storage solution in farms in North Africa, as well as their impact on the socio-economic environment in rural areas, and develop workable market models for the farms. And using the data that will comes from the microgrid farms and the baseline study to simulate the best agricultural practices and the business opportunities. Analyze this data and outcomes and the discuss finding with the relevant public and stakeholders through a series of workshops that we set, and partially implement the integration of these optimized models with the microgrid on project farms. Also we have some capacity building, train the farmers and scientific staff on how to run the microgrids and these new processes. Okay, the results achieved so far, we studied the existing business models with farms having partial or no renewable energy. So we have identified and we are working on 3 farms in Morocco and 1 big farm in Algeria, Beladoni farm. And also we have a new pilot farm in UDES. For example, in concerning the farms in Morocco, what we can see is we found that people not only use diesel engine as generators, but also changed it from diesel to gas. So you see here a picture of people changing this diesel engine and use gas. So this is locally. Many of them have PV installed, whereas in Algeria the case is not the same, because the power grid integration is, we have more power grid access for these farms. I'm not talking about the south isolated farms, but in the northern area, they are grid connected. So their main concerns is about pumping. So pumping water needs a lot of energy for them, and it can use basins, so big basins, problems also evaporation, things like that. So this is the farm in Algeria, and these ones are in Morocco. Then with the money we get from this project, we bought and installed a greenhouse in this pilot farm, 13 kilowatt PV, geomembrane pool, water tanks and control rooms with inverters, with monitoring systems at a new pilot farm in UDES to have a small scale modeling. Okay, next slide, please. Concerning the PhD studies, so far we developed, we bought and developed this experimental bench. So this is a wind turbine emulator. So if we want to do studies, we have to emulate the wind turbine. So we have to apply the right wind speed and the right torque. This is TRL4, and we developed already the algorithms. This is in Tlemcen. This is in Nancy in Lorraine. So we have here the wind profile. We want to extract the maximum power from a certain, so it's maximum power point tracking based on tip ratio. So I can go into details if someone wants. And we also developed models of this system and simulate them. Double-fed induction generator models, LFP lithium batteries. So this is mainly in Germany. Okay, they also have an experimental bench there to test and validate these models. So far we have 1 journal paper, 5 conference paper, 1 is submitted, and we also organized 1 conference. Next slide, please. The work that is in progress is the installation of the monitoring devices at pilot farm in Morocco. So this is in a Rimsar farm. So this is very, very recent results, like last week. So we installed how these sensors to monitor the water in the soil, and also weather condition, also power measurement here, the consumption of the pumps and the production by PV, and we send them over the internet. Next slide, please. We also had our first annual meeting where we invited all the consortium partners to the first site in Marrakesh. So it was in June, and we presented our works and we have face-to-face. It's very important to meet face-to-face. We are using Teams or Google to meet, but making face-to-face, and it consolidates the consortium links. And we also visited the pilot farms I showed you in Morocco and the Green Energy Park facilities. So these are the farms, one of the farms we visited. So far the difficulties that we had, mainly the procurement and the installation in Algeria and Morocco. So we have a lot of delays for that. So this is why we have some deliverables that came a little bit later than we expected. Also, some of them were delayed because we need some on-site surveys and studies, and then the models depend on them, so everything is linked. We have 2 PhD theses out of 3 that were delayed. So one started on 1st January, and the other one just started in September. So this has personal issues. But the first one, the Algerian one, is because we had to find, you need for, I can talk about it later, perhaps, but you have some policies to choose this PhD student from when you have this co-tutelle, so co-supervision between 2 countries. The difficulty is that the policies are different from country to country. Next slide, please. So we expect from as a result by 2025 is designing the prototypes, the microgrids, the battery, and the data interface, the procurement and installation of equipment for storage and microgrids, including data monitoring equipment, optimizing the existing installation, because what farmers need, and what we had as direct feedback, is that they want us to solve them some real problems. For instance, they have 2 farms distant by 500 meters, and they don't want to spend too much money, how they can connect them by AC or DC links. So we have to propose with the existing materials that they have solutions. So we are differentiating what is the part of research, science research, and also applied fields. Training data collectors, farmers, microgrid users, monitoring of water, energy consumption, agriculture production in the farms. Communication and stakeholders engagement, and of course PhD defense, publication in journal papers, participating in international conference. So next slide, please. So what's the become of the consortium set up on this project? We will continue PhD co-supervising between North and South countries. We have strong links now. We are working on the same topics. We have a new cooperation initiated thanks to the result of the project. For example, with the Pan-African Institute of Water and Energy Science, PAWES, which has a Pillar 2 in LIPRI. We have two main things we have to deal with is the dialogue with policymakers and other stakeholders for research uptake, and promoting digitalization and entrepreneurship in Africa's energy sector. As new collaboration plan for the future is regarding the residential. So we want to push from microgrids for farms to microgrids for villages, and they have different concerns, mainly because the load profile are different, smaller energy demands, but multiple ones. So the concept can be different, but the modeling and the sizing that we are developing will help us. We have new funded projects and funding application. For example, with Switch project, we were approached to initiate new collaboration. So this one is a second call, the second call of LIPRI, so 2023. And we also applied for a project, a PRIMA project. So we were selected for applying to the second phase, and we are waiting the decision for December. Next slide. So the expected outcomes by 2030, the baseline study of on agricultural practices and socio-economic environment of the participating farms. So the data will be analyzed using appropriate simulation models for the purpose of extrapolation, because we are dealing with small farms only in the north. So we have to export. Of course, all these projects are to enhance the growth of agricultural exports. Okay, I'm finishing. And the improvement of food and energy security, provide new prosumer-type energy production and consumption models, and the nexus of energy, water, agriculture, and digitalization in rural areas. Proposition of new electrification schemes in rural area that are not connected. Okay, next slide. And last one. How we contribute for this EU research and development partnership. So far we are building, we have capacity building. We help our colleagues to how to set up new experimental bench, how to apply for international projects, and all this stuff. And regarding the interest of consortium members in participation in LIPRI clustering activity, we want to go into three areas. The data collection. For example, I had a lot of information yesterday and today people gathering data, okay, but what are the common format of this data? How we can exchange them in the future? So this is an important thing, and people from computer science deal with JSON format or what's are well formatted for that. So we need to have something that is common in order to exchange data between us, between all these projects. And so we have expertise in setting up experiments and testing, so we want also to participate and share in that. And for this material 1, 4, and 5. And thank you for your attention.
So thank you for the presentation of the project. So I see already one question there.
Okay. First, thank you very much for this very interesting presentation.
Thank you.
And I think it's quite a success. I have two small questions regarding some details of your presentation. The first is about, I was surprised you mentioned the fact that in some case, probably for the pumps, for this kind of thing, the farms switched from oil to gas. Which kind of gas and in which country? Because if you are in Algeria, I can understand you can get gas. In Morocco, it's much more difficult. It is natural gas. So what kind of gas is it?
No, it's,
okay.
I don't know, in bottles, as you saw,
okay.
If we can go back to the slide
it's
of the
okay.
photos, you have,
big
it's small gas, yeah.
Okay.
So it's a matter of cost and also availability.
Okay.
So we were surprised, and you are concerned with the security? No, don't use that. So we need urgently to put renewable energy and to get rid of this because it also causes problems, security problem.
Yes, okay.
Because they do the modification by themselves.
Okay. The second question is about the size of the farms. I suspect that to develop your project, you need a relatively big farm. So is it, as we can say, individual farms or collective farms? Do you have collective farms in which you can implement? And according to you, can you implement this kind, of course, my question is a bit stupid, but can you implement this kind of project in any kind of farm, in any size of farm?
Exactly. Thank you for this question. Yeah, we targeted many models. So we have a pilot farm of 13 kilowatts. So this is a very small one at UDES. So this one will be implemented. It's in a research center, so we have total autonomy on it. And we have small-scale farms, like for individual ones, 20, 30, 40 kilowatt, and we have big farms. Like the one in Algeria, it's a very big farm. I don't recall it, 200 hectare. I'm not in agriculture, but it's a very big farm, state one, yeah. So we will have models of different ones and to do the extrapolation. But mainly these one are in the northern area in Algeria, and the one it's in middle near Marrakesh, the farms. So we didn't target the southern desert area, but we have another project that will deal with that. If it, okay.
Yes, but before there was behind you, from Irsin. Yes.
From Irsin.
Okay, thank you for your presentation. So I have two small questions. First one, why do you call it microgrid? Because by definition, microgrid is a distributed load and distributed sources. Now I can find PV, solar PV and loads pumps. So how it is distributed, your loads and your sources? So if it is in the case of one farms, how why do you call it microgrid and not hybrid energy sources system?
Okay. I answered the first question, so I will remember. So the first question is about why microgrid. Because we are connecting farms. We are only powering one farm. We have neighboring farms, and for example, one could have the PV, the other one could have the wind turbine or small PV. One could have batteries, the other one cannot have, and they share the resources. Okay, so this is the concept. And also, these things of plug and play is that if one of them stopped working, for instance, the generator is out of usage, then, and he was the grid former, so he was imposing the frequency, then he stops, and another one what was grid following, he will go to a grid forming without human interference. Yeah.
Okay.
Second one.
So this is a really a micro. So the second question is about the battery, the choice of using battery. As you know, the pump demand, there is a high current demand. Yeah. So I don't know if you expected nighttime irrigation and because the battery cannot be suitable for.
I will answer that. I know exactly what you want to say. Okay, so farmers are against batteries because they cost a lot. So the battery studies in our project will be on scientific parts, so in labs, okay? And we will provide solution. I say, okay, if you do like this, it will cost you, but you will have the flexibility of doing this irrigation by night. If you don't have water tanks up in height, so you use gravity to irrigate, or you irrigate by day. So we size the pump, the PV, or what else as generator as maximum power for the pumping, because to irrigate the power is much less than pumping. Okay, so you pump in the day, and you can also take the power. For example, you have PV1 and PV2 in 2 farms, and you use the maximum power of the sun to pump for the first one, and then you use the maximum of the 2 to pump for the second farm. And this is
just one recommendation. I think storing water can be suitable than storing energy in the battery. You can store water.
Perhaps not suitable, but less expensive.
Yeah, less expensive.
Yeah.
Okay.
Much less.
Thank you.
Thank you. Yes. Well, thanks a lot. I would like to congratulate you because it's a real and experimental project, and the feedback may be very interesting, I mean, for further projects.
Thank you.
I also take the opportunity to make a remark. I didn't see, for instance, one partner that may be useful to this project, which is INRA. I think for the agricultural part of the project, it would have been very interesting, I mean, to get them involved, especially when we talk about farms.
Yeah, I will answer this. In fact, we rely on the farmers themselves, having their expertise when going into crops and growing vegetables, etc. So we didn't go to the institutions because we don't have a scientific aspect of the study of the project in our project. So it concerns the production. We go to the farmers, the stakeholders, so all this kind. But for the studies, for the PhD studies or relevant one, we went to the institutional, the research institution, in both countries.
Yeah, the second question is, it's not a comment. I think that we would expect that you will, at the end of the project, standardize the use of such approach of smart grids, telling, for instance, if you are in a certain point or local, we have certain energy needs, we have certain water needs, so we need this kind of size of plants and so on and so on. And this maybe will help the policy making decisions. And so
exactly. Not only at state level, but also by cooperative farmers. If they want to put renewable energy in the system, they will come with. We will come with a scheme. We say, okay, you have 5 farms to connect. How much is the superficie? What are the water needs, etc. And this is the configuration we think is better for you.
We have a question from Anjali. The microphone, please.
Thank you very much. I'm Anjali Shankar, one of the evaluators of the project. So, yes, again, thank you very much for this very interesting presentation. And
thank you.
We really feel that you are not very far from technology readiness. So my question relates more to whether during the last phase of the project, have you planned on giving some thought to the business model? Because especially if we say now that we're going to try and optimize and connect many farms amongst each other, the question will be who is in charge of the equipment, what is going to be the billing, not only the management process, but also the billing process of all of that. So I'm not saying that we're going to resolve all the problems, but as we've also been asked to assess when we look at your projects as to what could be the possible next phases. We feel that we are maybe not very far from market readiness, and it would really be interesting to hear a bit more as to how far the intention is to go in terms of the business model and what possibly we could do for accompanying the project further.
Okay, thank you. Okay, I'm not the best person to answer this because the guys from our custom ship are more in MEE and in TU Berlin, Christian, who can answer this. But this is the work. We have a work package dealing especially with that. So we are targeting that no matter. They had some delays getting the surveys, and we have already the contact with the stakeholders and also the local authorities. For example, in order to access this farm, this state farm, there was huge efforts they deployed to get it. So, and we learned from that. So now if we want to go to other farms, we know the protocol. We know where door to knock in order and who are the persons that are interested, because the farmers are interested. But the hierarchy, you know how it works, it's complicated. So we have all these models, and we will write it. So, but the person that address, also in the report we write it, in the mid report we write it, the one that we send you, François.
Thank you very much. And I think if there is a recommendation, there was a technical one, but I think the recommendation to work strongly on the working package going to market is very important. It should be a recommendation, I think, that you could get back.
Yeah.
Thank you. Thank you very much. Thank you. So we will have now another project on productive use of renewable energy, dealing with the purification of water. So the project is called Let's Sol. It's a project managed by Romania, and Irina Mocanu from Romania is there, and she's coming. Welcome to present Let's Sol achievement at this time. So, Irina, you have...
Yes, yes. No, thank you.
The slides are already on.
I'll put our backpack with the water. Okay, it's part of it because it was hard to bring everything. Okay, hello everybody. I'm going. Okay. So hello everybody. My name is actually Oana Kramariuk. I'm the CEO of the coordinating company, and Irina Mocanu, the coordinator. I believe either she's teaching right now or attending online. And so thank you for the opportunity to present our Let's Sol project. So Let's Sol stands for enabling clean and sustainable water through smart UV LED disinfection and solar energy utilization. And the consortium, as I mentioned already, is led by an SME, a Romanian SME. And the partners are Technical University in Finland, and then we have a partner from Togo, the University of Lomé, in particular the Laboratory of Applied Hydrology and Environment. And then we have Algeria. Yeah, this is complicated. Okay. Then we have Algeria, EPST, the Unité de Développement des Équipements Solaires, And then we have German Institute for Social Research and Social Economy with my colleague there in the back, Catherine, attending. And as the title of the project is saying it, we are focusing on drinkable water, on clean water. And in the aim of the project, there are several key words which are important for the following of my presentation, namely, we are providing off-the-grid clean water, so not from the system, communal system, through the use, and now smart, portable unit, so smart, portable, and then we have UV LED disinfection, augmented with classical decontamination and powered by solar energy. So sources, and we are actually renewable, but in our case it's going to be solar. So we have, I will try to tackle these aspects of our project in the next slides when I'm going to talk about the results. And first of all, our project is relevant for the roadmaps of the call as outlined there below for Mars 1 and for Mars 3. And I will not go into details about this because everybody knows already. Thank you. Our initial objectives, so they were, still are, some are on the way to being achieved, some have been achieved, and some will be achieved by the end of the project. And those are the development and optimization of the UV LED irradiation. And we believe this is, let's say, the most novel part of our project. You will probably ask, either now or later on, that there are other UV LED irradiation devices, especially with COVID, that has been growing in number. And so some particularity of our approach is a combination of UV LED, of UVA, UVB, UVC. But I'll go into this detail about a bit later. And then development is not maybe the best wording. We are going to optimize and test the solar energy modules, which will power our system. So development is not maybe the best because we are not going to develop any solar energy panels ourselves. We are going to make our device smart, so that's our aim, by developing some software which will integrate data from various parts of our device. We also have wireless positioning and tracking algorithms. And actually, even now, my phone is not here, but we are basically collecting data for this algorithm. We collected data here in Kigali, on the way, everywhere. All of us are collecting a bunch of data to improve this algorithm. We are going to pilot our development in Algeria and in Romania and in Togo. And one of our aims is that the system which we are producing will be suitable for the people for whom it is meant, and it will be, let's say, accepted by them, and we hope in a future, which hopefully will not be very far away, to be able to bring this system to, in our project we have like 100 systems by 2030, I think. So with respect to the suitability and development, like a user-centered design, we have had already on-site surveys by the ISO Institute in Togo and Algeria. And we have reported this survey in a journal article, part together with other data. And you can see two pictures here. The result of this survey, I think, in addition to understanding how needed such a system would be, and understanding the ways people have, get nowadays water and use it, and what kind of water. So in addition to that, our survey also helped. Actually, it's not much help. It makes our work a bit more difficult, but you will see we have architecture of the system on the next slide. Okay. And this is the system in the first rectangle. You see the system components, and then the solar energy panel, the positioning. Okay, and what the survey said is that actually our idea of a backpack might not be the most suitable one, although I think we will start with the backpack, which I have there. But people apparently carry women who are a lot in charge with water fetching, carry their children on the back, and they would like the system to be in a basket on the head. So we will see how we can solve this. But we will start with the backpack. But that's, let's say, an important finding, which we didn't realize at start. So if you go to the next slide. Thank you. So this is the design of our UV LED module. So this is the first backpack. It's a bit bigger than what we anticipated and what I can nicely carry, although I'm not very tall. And inside I have some of the components. We made it, okay, thank you. We made it bigger. Okay, thank you. So we made it bigger such that we have place to play with the components, and I have brought some of them. So this is our UV LED disinfection unit. This is fully our design after several iterations. That's a mechanical filter for particles, and here are tags. I have a small pump here, which will push the water inside the system. There will be another pump here to fetch the water from the water source, and this one will circulate it, and there will be water tank with dirty water, so to say. Then we will have a carbon filter. We will have a clean water tank and accumulators. And okay, there are some more details like with the solar panels, but I didn't. So this is the main idea. And we have the components. Okay, I didn't bring all, but I wanted that you get an idea. And obviously, these are connected with two tubes and everything. Okay, so this is the water. Thank you. This is the water. This is the water disinfection unit. And we have tested various properties like the disinfection power, the radiation power along the tube. We have adjusted the length, and when I'm returning, we will do the first real water tested. We have fetched water from our lakes. I can guarantee you it's a good testing sample in Romania as well from Snagov. And we will do the test. So these are the elements of the UV disinfection. And on the right, you will see the setup we will use in the lab. And that lab setup is different than what we will use in the backpack, because the idea is that you should be able to disinfect between tests thoroughly with harsh agents. So we have a peristaltic pump, where the pump doesn't come into contact with the water. We have a flow meter. So we have the tubes are out of a material which is non-flexible, but which is cleanable. So this is our setup, and we will test it first in Romania and then send it to Algeria and Togo. They already have started to purchase the power sources and the Berzelius glasses, and then we will send the rest to them. And actually, we will meet with them in person in Finland in December so that they get instruction manual and instruction from us. What we also did in preparation of the pilots is that in Togo and Algeria, water sources were analyzed. And you can go on the next slide to see the quality of the water sources which are in use now in the regions which we are targeting for our pilots. And all what is in red is bad. And sometimes it's really bad, like orders of magnitude higher than the maximum allowed values. So we will test our system against this water. And if we achieve our goal, then I'll drink myself. So hopefully that's where we will get. Okay, so if you go to the next slide, we have been also working on optimizing and sizing the solar panels, which we selected to be appropriate in terms of weight and affordability and tunability and so on. This is our partner from Algeria working on this. We have considered the various consumers in the system, and if you go on the next slide, we have evaluated the needed power and which is the element which can be optimized if the need arises, and the sizing of the panels will be the next step. And in this respect, we are collaborating. We had some discussions with another LIPRE project. They will be in the sessions in the evening, and they are working on solar cells. And we discussed with them that they test the, let's say, the recovery, not recovery, I mean how much waste our solar cells would produce if they would be released. I mean, they are on the environmental impact of solar cells. The localization and implementation testing, so they are meant for making a map of water sources. Also, and that I know it's sensitive, and probably somebody will ask me, tracking the movement of the backpack. And obviously, if the movement is associated with a single person, you will immediately address this. But we are aware of these aspects, so we are considering. And if you go on the next slide, what we are doing, so we have asked people in Algeria and Togo to collect data with their usual mobile phones. And what you see in that table is the performance of the localization with various mobile phones. So we are collecting data in Europe, all our colleagues, but in addition, they collect with theirs. And obviously, if you look at the data, you will see that in some cases, like the second phone in the second phone in the row, it has really poor localization because, and that's the job of our Finnish colleagues, because there is only one satellite system which is visible with that phone, GLONASS, I think, it's GL, and so they can't combine data from more systems. So they have, with that particular phone, they have a low accuracy, localization accuracy. Okay, next slide. So we believe we are now at TRL 4 and 5, depending on the different parts of the system, and we aim to achieve 6 and maybe more. Let's see. There are different constraints for our system, as you can imagine, as I mentioned already, price, weight, then technological constraints, and so on, which we must take into account, and we are doing this. In the next slide, please. By 2025, so that's the end of our project, so we are really at midterm now, we expect to have an integrated and validated system, validated in 3 countries, pilots results from these 3 countries, a business plan for future commercial exploitation, and we have been working already, it's advanced, but we need some more on-site data and information on the policies and so on. And wide-scale scientific dissemination and the strategy for future cooperation. So that's by the end of our project, and then by 2030, if you go to the next slide. So we are at the regulation part in our business model. So I can't say about regulations in Africa right now, but obviously if it would be a system in Europe, the system should be CE certified, at least, if not more. Whenever you work with UV, you have other certifications to keep in mind. So we want to solve this problem in the future. We hope to have, that's a dream hopefully coming true, to have about 100 lead salt units in use. And our company is interested to invest also after the project, both our own work and also look for new projects and continue the cooperation. And we will look for new projects by applying to common grants. And if you go to the next slide, please. Okay, that's basically what I already said, and I only have 2 more minutes. So if you go to the, I think it might be the last slide. Yes, so thank you. And if you have questions, please.
Thank you very much. So we will take the question. Yes, Anjali, Shankar.
Yes, thank you very much for this very interesting presentation. I would like to pick up on one point that you made at the end of your presentation, which is that you hope to have 100 such backpacks tested and working by the end of the project.
No, it was further end. So the first results were by the end of the project, the other ones went 2030 as required by the template. So we were supposed to. No, it's not realistic by the end of the project. We would like to, but I don't think it's realistic.
Yeah, so that was basically my question. By the end of the project, how many do you think would have been tested to test their acceptability?
Our plan and also our money, because that's also an issue, we are planning to build 8 devices.
Okay, and what would be interesting is not only monitoring the social acceptability and so on, but have you planned on looking at the cost and the possibility of local manufacturing?
Yeah, local manufacturing we didn't yet approach. We were asked recently, I think in these days, yes, in the business session of yesterday, we were asked how much it would be if we would manufacture it locally, and it is a very good question, and we have to look into that.
So do you think this could be integrated in till the end of the project, or this work?
At least the information, yes. At least the information to some extent, obviously. Not everything can be manufactured. And also now we are not manufacturing everything. You buy the LEDs, there are dedicated companies. But assembling and maybe like for example, the carbon filters, they are going to be produced in Togo and Algeria, also within the project. And I think, for example, those we can envisage to produce them here and assembling. Yeah, but that's a very good and a very smart approach, because we hope to get it cheaper. So.
Thank Thank you. I have a second question at the rear of the room, and after the bed, and a fourth one. So here at the rear of the room.
Thank you very much for the presentation. Patrick Nussbaumer is my name. I have two questions, and they both relate to your ambition to turn this into a commercial operation. The first one is you made the argument that your UV disinfection technology is different to what's on the market and arguably superior, no? My question there is, have you considered intellectual property protection?
Yeah, sure. Sure.
Just making sure, in case you want to go into commercial operation, that
we already researched because the difference. Sorry, please. I will answer after. Yes,
both my questions are connected. The second question is the willingness and the ability to pay for water is typically very low. So not a huge income stream when it comes to the business. No? But I was intrigued by the fact that you are also collecting data, and data has a value. So have you considered monetizing that data and increasing that as an income stream to the money that you can get selling water?
Okay, thank you. So regarding regarding your first question, we know where, at least we suspect where the novelty lies in our approach, and we already looked at the existing patents. So yes, we have taken this into account. And that's in the combination we propose. It's written in the proposal. We propose to pre-treat the water with a combination of UVA and UVB, and then come with UVC. There are some studies showing for UVB that it's conditioning the disinfection through UVC. So we will, and our software is supposed to optimize this balance, the interplay between the three wavelengths, and this is where we think the novelty lies. Okay, and for your second question, which data would you have in mind? Because the data which we are collecting, we are planning to collect, is related to mapping and localization of, let's say, water patterns, water sources. Is this what you had in mind?
So, no particular source on what kind of data you can treat. I'm just trying to think with you on your business model and how you can strengthen that additional.
Okay, thank you. So what we think that it might be more realistic to commercialize are the algorithms, the trained algorithms. We want to use AI. Everybody wants to use AI, ML, and so on. So we want to do it as well. And we believe that the trained models might be more easy to sell than sensitive data. Thank you.
Thank you. Nabet?
Well, thanks a lot for this portable solution. I have very simple questions. The first one is related to the process of UV disinfection. When compared to simple chlorine disinfection,
yes.
Could we compare that? Is
so actually it is compared in one of our articles. You mean in terms of
costs, of output results, and whatever.
Output results, I would say that they are better. Better taste, less damaging for your body. The cost, I can't comment. So I know our costs. I didn't look into the cost of chlorine disinfection. So we calculated an average cost based on an optimal throughput of our system to be 0.9 euro the cubic meter of water. So we calculated that a household could pay like, I think it was, I wrote it here down because I was expecting some questions, 0.2 euros per day per household.
Yeah, because I think it will be a very convincing parameter when it comes to widespreading such a solution.
Yes, I will look into the chlorine. Yes, I think from taste, toxicity, and so on, we are well. But the cost, I can't comment on those.
Okay, last question. What are the risks related to the use of UV to the human being?
There are risks, and you know there are nowadays certifications, and we obviously one problem with such a system is that if it's used as it's supposed to be used, then it's fine. But if people start playing with it and taking the LEDs out and so on, then it's a problem. Yeah, and kids play and so on. Yes, yes.
We have a last question, I think. Could you raise the hand? The one who raised? No.
Okay. Okay.
So thank you.
Thank you. Thank you.
Very interesting. And thank you bringing the device. It's very more concrete to see. Thank you very much. So some news is that pyro biofuel could be presented since Fatma Ashour is connected right now, but we will finish the session first on productive use with the Sol Charge E project, and then we will split to pyro biofuel back. So Fatma, who are online, stay with us. We will give you the floor after the presentation of Sol Charge E. So Sol Charge E will be presented by Corbinian Goetz, sorry if I don't pronounce your name correctly, who is in line from Germany. So Corbinian, you have the floor right now. Could we hear you?
Yes.
Yes, okay.
Thank you for the introduction.
So thank you for 20 minutes presentation, Max. Thank you.
Thank you for the introduction. So welcome everybody to the presentation of the project Sol Charge. I'm sitting here with my colleague Meli Menelaos from South Africa, which is currently in Germany as well. Please, the next slide. Next slide. Yes, thank you. So our consortium exists of 4 countries and 4 partners. So the first one is in South Africa, the Stellenbosch University. Second one in Ethiopia, the Adama Science and Technology University. And 2 partners in Europe, which is SEA from France, where also our colleague also joined, and TUM in Munich in Germany. So what's the project about? Sol Charge aim is to combine standalone systems with productive use cases. And in this very specific case, it's electric mobility. So we see a very big rise of mobility in Africa. However, our target is to leapfrog fossil fuel-driven transport and all the emissions which come with it. And the second point is, and that's the important part where the standalone systems come in, is to enable access to markets for rural population. We see that especially in rural scenarios, there's a lack of mobility, which is a problem to prosper, to get access to healthcare, to markets, and that's what we want to tackle. And therefore, our project is related to MAR3, Smart Standalone System, with the big problem, for example, here 2 examples from Ethiopia and South Africa. In Ethiopia, 80% of the national population is without sustainable supply of energy. And in South Africa, it's 8 million people without access to electricity at all. So on the next slide, the important part is, we already heard, for example, quite a few productive use cases, because the big thing is renewable electricity, especially in mini grids or a standalone system, must generate revenue. However, how can we generate revenue? Usually we have big upfront costs for the whole system. So therefore, we must run the system over a long project time frame. But as well, we should have heavy load on it so we can sell a lot of electricity. And our use case is mobility, which is a productive use case. In this case, you can already see the example. So our idea is we combine, for example, in this case, you can see one side of us, PV with the A car on the left side, which is an electric transporter, four-wheel drive. And the idea is to transport agricultural, for example, agricultural goods to markets from rural scenarios. And that's maybe our solution is called a decentralized transportation hub, because we are able to put it basically everywhere without any grid connection. And by that, enabling an access of this spot where the DTH, the decentralized transportation hub, is to nearby markets or big urban scenarios. So how is our implementation looking like? On this slide, you see an overview of Africa, where we have our two implementation sites. One is in Ethiopia. There we are using this four-wheel drive transporter, the A-car, which is electric, and combining it with a solar charging station with stationary storage. That's the one side where we are really using it in an agricultural use case. However, in Africa, in South Africa, we are using a mellow van, which is this three-wheeler in close to urban scenarios, and also coupling it with a standalone charging station. You might see there's a difference especially between the vehicles, and the idea behind that is to show that our solution of the decentralized transportation hub is scalable and parametric, because our idea is to not just implement it at those two sites and show that it is working, but also give insight on how it can be adapted to the circumstances which could be somewhere else. So if we look now on our work plan, our whole project is basically divided into 4 system layers. The very first is the design of the standalone charging station. With the standalone charging station, the second layer is to combine a business model, because in the end, we see the DTH as a possible solution for investors. And therefore, we want to give, for example, an idea how you can run such a station. We want to train people on how to produce such a station, and also the business model in our capacity building part. And last but not least, we provide a solution with renewable energies and electric mobility. However, we still want to assess this in terms of life cycle sustainability. And therefore, I want to give over to my colleague Arif on the design of the charging station.
Okay. Thank you, Dr. Nian. Okay. In here, we support the STU for designing the SCS. With the STU data specification, we resize the configuration using PV6. In first step, we define the coordinate of the site where the SCS will be installed. In the Ethiopian, we set the HDB itself to coordinate for obtaining meteor data of this location that used in the previous simulation. And next step, we determine the orientation of the PV models, which the PV SCS will be installed with 15 degrees tilt and face to the south. And then the load profile for SCS is determined which a car, electrical vehicle, become the load. Using data from manual sheet of a car, we set the load profile, which the EV with a nominal power 3.3 kilowatt needs 7.5 hours for the recharging process, and the load profile sets content over the year, and load activate after work activity. And for the system, we set the resizing site. We set the probability load of loss of load and day of autonomy. And after that, we set the numbers and size and brand a component like a battery, PV, and control. In let's scenario, STU use 14 PV Linu, 6 battery, and hybrid inverter day 5 kilowatt. And then after that, we set the default loss from PVC for thermal loss, because we don't have the information from there. And enter the cable specification from STO information for input cable loss calculation. About the shading, we based on the information STO information, there is no shading in the location. And then we simulate all the input parameter and we obtain the result in crop table and CSV file. And then the result could be used for the economic evaluation, which BVC provide this feature. Next slide, please. Okay, thank you. This slide contains the result of SCS simulation from 3 scanners that given from ISU Ethiopia. In here, we take 2 KPIs, such as minimizing missing energy and unused energy. Missing energy is occur when the SCS could not supply energy to the user, and unused energy is the surplus energy that is produced by SCS after the supply energy to load and recharge the stationary battery. In our scenario, we found the SCS that recharge for 100% or the missing energy is 0. However, the system will waste much energy, we can call unused energy. And then in the infestation and investment, and the system is very expensive. And then considering the missing energy, unused energy, and investment, we recommend to install the ACCS with a 16 PV and 8 battery for the first scenario, 10 PV and 4 battery for the second scenario, and 14 PV and 8 battery for the third scenario. Okay, thank you. Next.
Hi, everyone. So as Corby mentioned, my name is Meli and I'm from Stellenbosch University. And I would like to discuss a few of the practical aspects of our project so far. So as you can see on the picture on the left, the ACAR has been in the operational phase in Ethiopia over the past few months. And the team at ASTU is working with the team at SEA, and they're finalizing the design of their off-grid charging solution. So in Stellenbosch, we've been working in parallel with our own prototype charging station. And we've purchased our own EV. As Corby mentioned, it's called the Melavan. It's a locally manufactured sort of tricycle system. And it's mostly suited to urban last mile delivery applications. So we've made progress in the prototyping of the charging station to charge the Melavan. And the philosophy we followed is to implement a solution that utilizes easily available and non-specialized components to ensure that the design can be easily reproduced all over the world. And it also makes the implementation easier in case there are any components that are not easily available. They can be easily substituted with an alternative manufacturer. And that was our philosophy there. So the main components of our system include the PV panels for the energy. And then we make use of a maximum power point tracker to ensure that we are always extracting, or the PV panels are always at their maximum power point. We use a charge controller to ensure that the battery is charged efficiently and safely. A battery for storing the energy during periods of low sunshine. So in our cases, we'll be charging the vehicles overnight. So the battery has to be considerably sized, but it also helps in periods of poor weather. And then, of course, the last component is the inverter, because the vehicles that we use make use of AC charging. In the image in the previous slide, please. Yeah. So in the image in the middle, you can see the prototype charging station that we've assembled in Stellenbosch. This one has been more for a lab setup, and it was designed to charge the Melavan from 0 to 100% on a daily basis, and we've assumed that charging takes place overnight. We also have sized the inverter such that we would be able to charge 4 Melavans simultaneously, but that would only allow for 25% charge per Melavan. The resultant specifications of the system are 5.5 kilowatts peak of PV panels, and they've been designed to be north-facing at a 15-degree tilt, specifically for use on shaded parking. And they are oversized because they need to supply enough power in the worst month of the year. which would be June for us. So we do have a lot of surplus energy that we have to use for something else. Then in terms of batteries, we have a 15.3 kilowatt hour system, and these are second life batteries. They were previously used in an EV, and due to their degraded capacity, they're no longer suitable for use in vehicles, but perfectly fine for stationary applications. And this is to keep in line with circular principles. And this can fully charge our vehicle while not exceeding an 80% depth of discharge. And then finally, we've opted for an 8 kilowatt inverter that has a built-in MPPT and charge controller. And this is a hybrid inverter because it allows us to tap into the grid in order to reduce costs from oversizing batteries and also increases system reliability in cases where it's necessary and available. We've tested the system and it's been found to be capable of charging the vehicle as necessary. And we're currently busy with the development of version 2 of our charging station, which will be far superior to this one, hopefully completed by the end of this year. Thank you.
Next slide, please. So as you saw, we are trying to work in parallel as much as possible. We also had a few funding problems in the beginning, or still have, and problems we need to tackle from sourcing. However, our approach is to try to work in parallel and do small steps iteratively. And therefore, as Melly already said, our main idea for the whole system is to make it adaptable wherever it is needed. And therefore, we together as mainly contributors, Stellenbosch University already published development guidelines, which can be used for sizing such a system. And we also showed one part of the simulation on the EU PVSec conference. So what's next? As you saw, our idea is basically we have a decentralized transportation hub, which is very off-grid in rural scenarios and supplying electricity for mobility. However, we got a new case or a new idea, which we are currently developing in a student project together with Stellenbosch University. Our idea is to add to our decentralized transportation hub electric tractors in order to produce also the goods, and therefore we try to push this topic and also make research on which productive use case really makes sense in order to make such a decentralized transportation hub economic. Thank you.
Thank you, Corbinian. Thank you both for the presentation. So we'll take a question in the room, not too many, and short question because we are late on the agenda. So where I am looking, I will hope I didn't discourage you for any question. Yes, one Anjali there.
Well, thank you very much for this very interesting presentation. What I was wondering is, do you have any numbers in terms of what would be the capacity for one such transportation hub? And well, what kind of agricultural vehicles are you envisaging? I mean, you've talked about a tractor and small trucks. So what's the technology that we're actually looking at? And what would be the capacity of these machines?
Thank you for the question. Unfortunately, internet was gone for a short time. However, I think I understood it. So I'm just saying the question again. I think your question was, what's the capacity of such a decentralized transportation hub? So our idea is to have minimum one vehicle, which can basically transport all over the day. However, there might be a sweet spot at 2 or 3 where we can make the DTH more economic due to economy of scale with the PV system and the stationary batteries. But that's still under research.
The question was also the type of agriculture vehicle you envisage.
Okay, so currently we are using the A-car, which has a battery of 36 kilowatt hours. So that's I think on the top end of one vehicle and what we can cover for one day. If it comes to really electric tractors, we're on a lower power scheme, about 20 kilowatt to maybe 40 kilowatt.
And at this stage, these vehicles are manufactured where? In Europe or in Asia or Africa?
So we don't want to stick basic to one exact vehicle. In the end, it's about technical parameters, I would say. It depends really which vehicle fits in one use case. So the Mellow Van is manufactured in South Africa locally. Unfortunately, the A-car is not yet. It was developed for Africa, but there's no local production yet of it. It's still manufactured in Europe.
Okay, thank you. Other question? Yes, Labed?
Well, thank you for the presentation. As far as I know, the proposed solution may be good for the urban zones. For the rural zones, as far as I know, in Africa, you don't have so far electrical vehicles. So I don't know. I would like to hear from you. What justifies, I mean, if you are targeting the rural zones, it's very difficult to find, I mean, electrical tractors or whatever, trucks, or how you justify that?
Thank you for the question. Definitely, that's a big, important question, and it is on a future scale. However, our ideas, we see in especially the spots where we are in Ethiopia, for instance, that there are big problems in the supply chain of fuel for rural areas. There's a lack of fuel, it has bad quality, or it is very expensive. And if we are now coming to scenarios where we have cheaper electric vehicles, and we would like to run them locally from the energy which is locally produced. And thereby we can basically tackle those two questions. On the one hand, to make mini grids or standalone solutions economic, and on the other hand, basically drive electric vehicles with locally produced energy and without the need for a big supply chain of fuel, and also, of course, without the emissions.
Yeah, thank you. Just the question make me think that in South Asia, in rural areas, there is already a lot of free wheels vehicles in order to transport agriculture products and so on. So I think there could be some applications in rural areas. Okay, thank you very much for this presentation and for the question. We will go, because we are slightly late, to the project we slipped, Pure Biofuels. Fatma Ashour, you are online, I hope. So you will have the floor for 20 minutes presentation. I recall that it's a project dealing with clean cooking and biomass transformation. Fatma, you have the microphone open.
Yeah, thank you so much. And then if you would like to, I would like you to accept my apologies, because I'm just back from Paris. So all my schedule have been reshuffled, and I had a class in the morning. So I'm really sorry. Okay, so our project here, can we pass to, yeah. We are a consortium made from Cairo University in Egypt, and two institutions from Morocco, one Ibn Tufayl University, and the Research Institute for Solar Energy and New Energies, which is the IRSN in Morocco. We have another university from South Africa, which is the Wits University, the Brandenburg University of Technology from Germany, and the CNRS PIM in France. Okay, the aim of our project was to create a unique knowledge infrastructure that supports decentralized, sustainable, and cost-efficient conversion of biomass to sustainable fuels relevant to both Africa and Europe. So we had that the pyro-biofuel will design and validate innovative processing technologies, including a compact catalytic Fischer-Tropsch synthesis reactor and the hydrocracking reactor that will increase the efficiency of the fuel conversion process. Okay, so we would like to create new fuel. Okay, what were the key challenges addressed by the project? Of course, the increase of availability of advanced biofuels and energy in Europe and in the EU and Africa through inexpensive standalone system. Okay. Also, the introduction of tailored technologies using local renewable sources, because we have lots in Africa and of course in Europe of how to say, of waste, agricultural waste. So we'd like to use this. So this was a challenge, okay, for local use of population and economy to give them new chances. Okay, strengthen the European and African technology base and accelerate development of sustainable fuels to replace the fossil alternatives. Development of technical and managerial competencies and capacities in the area of biomass conversion, because not everybody is aware of that. And of course, in Egypt and in Morocco, we had the currency devaluation due, of course, to the international crisis happening and the war and everything. The late delivery of equipment, they were a challenge. And the export problems sometimes are challenges. What were our first expected results? We had a midterm expected result by the end of 2023 that the German counterpart will help in the synthesis and the characterization of the catalyst, highly efficient catalyst for the Fischer-Tropsch and for the hydrocracking, and a bifunctional Fischer-Tropsch and hydrocracker at small scale. Also, they wanted to develop the development of a combined experimental modeling approach for the microchannel reactor. It was very important because this will do the good conversion for the fuel, the obtained fuel. At the end of project expected results in 2025 were the synthesis and characterization of this efficiently produced catalyst to reach 70% conversion of the fuel, the implementation of the designed catalyst, and of course, the manufacture of 2 pilot scale pyrolysis rig at South Africa and Cairo University. So we wanted to manufacture or produce or import. In South Africa, they will import. In Cairo, we have manufactured the pilot scale pyrolysis rig. Of course, from the German counterpart, they wanted to have a successful hosting of the workshop on the use of hybrid technologies for Fischer-Tropsch and hydrocracking in the bioenergy industry. The completion, these were our modest, how to say it, results for 2025 to the completion of 1 PhD, but we are really aiming to have more of this, to have more of 2-3 theses, PhD thesis, submission of at least 3 publications to high impact peer-reviewed journals. Okay, the next, please. Yeah, and of course, the implementation of the design catalyst and the experimentation of the pyrolysis at the micro scale at the labs in Morocco and in Egypt. Numerical modeling of the processes done by the life cycle analysis. This will be at the IRSN. Validation of the integrated biomass to fuel conversion. This is what we will do on our pilot scales. We are going to upgrade the bio oil. The techno-economic analysis and life scale analysis will be done, of course, between all of us. The socio-economic impact study of biomass pyrolysis, because this will help women to get more jobs and to open new markets. And of course, it has been repeated here, to have successful completion, to have a postdoctoral training, submission of 8 publications, and of course, to host 5 successful workshops. Okay, we can go later. Next, please. Yeah, these were our activities. We had our meetings. We had periodic online meetings. They were carried out between all the partners. We had attended Professor Toko Mazoji from South Africa. He has attended the LIPRE first stakeholder forum in Pretoria in October 2022. We had the kickoff meeting in Cairo, November 2022. We have participated in the COP 27 in Sharm el-Sheikh in Egypt. It was in November 2022, with a poster joint between WITS and South Africa and Cairo University. We are all working together. We had this poster, production of biofuel and potable water using agricultural waste. We have participated in the IEA Bioenergy UNIDO online workshop in 22nd and 23rd of May in 2023. We had a meeting between the biofuel partners in Paris. It was at the Laboratoire de Procédés et Ingénierie en Mécanique et Matériaux in Paris. It was in September 2023. Unfortunately, I couldn't attend because I had a problem, but I came back. I was with the professor in Paris. I'm just back. Preparation of a joint review between all partners, the 5 partners, the consortium. It will be on the recent advances in catalytic fast pyrolysis. It's in the last revision of lignocellulosic pyrolysis of lignocellulosic biomass, approaches for improving the quality and production. It will be 79 pages, 5 tables and 7 figures. So this is in preparation and you have to submit it. Okay, please, next. These were the photos of our meeting in the kickoff meeting in Cairo. It was in person. It was there, but our French counterpart couldn't come because he had a heavy schedule. We had another one. This is the one in Paris. I was not there, but it was with the German counterparts, the Moroccan and the French. They were there. And of course, South Africa attended online. Okay, these were the publications. We have done many publications. All right, we had the comprehensive review of biomass pyrolysis, and it was in the conference, how to say it, prepared by Port Said University in Cairo, but all the publication will be published on Springer. The recent advances in biomass pyrolysis processes and bioenergy production, also the thermodynamic analysis. These are, some of them are between Cairo University and WITS. We have also one in the biofuel production from camel thorn biomass using pyrolysis process. It was in a conference in Hungarian, Polish, and Czech conference. Another one, these are 2. And the workshop by the German counterparts, they attended in Germany the sustainable aviation fuel design, because they are developing their fuel. And another one also in Berlin. And All this is on green and sustainable fuel from syngas via the Fischer-Tropsch synthesis process. Okay, please, next. Yeah, please, next slide. Okay, the technical activities, we have purchased the Cairo University pyrolysis, the Egyptian pyrolysis pilot equipment. At first, we aimed for the lab, a lab scale, but with the devaluation, we have asked for a local manufacturer, and gladly he has produced a pilot equipment. So it was our gain in this case. It was locally fabricated in Egypt. And we have made also a few modifications regarding the WITS counterparts in South Africa. They had communications meetings with the pyrolysis equipment companies. And also for the supplying companies, this has delayed the delivery of the components of the pyrolysis system. And they have attended at the factory in China a training week to be able to use the pyrolysis unit. We had our manufacturer, he gave us a guarantee for a year to be there, to the Egyptian one, to be able to modify whatever we want. Okay, so they in South Africa, it will be delivered in November 2023. Okay, and laboratory experiments were carried out on another devices in Egypt to complete until the completion of the apparatus. This on the right is the thermodynamic analysis and experimental study of alternative biofuels. Also, it is where we have attended a conference in Bologna it was a publication. The authors were from WITS and Cairo University. Please, next, please. This is the equipment we got, and these are on the left, the description of the equipment. And on the right, we have, this is the equipment, the pyrolysis, and this is the heat exchanger. And then what is burning is the syngas produced. Okay, of course, we were in the process of working on this, but this is why I'm sorry you find some of the biochar on the ground. So we are going to clean it, but we were in the process of implementing everything and adding the nitrogen cylinder and all this to, okay, so please next. Please the next, yeah, please. After this, I'll show the work of the others. So these are some of the presented work from the Brandenburg. I got some of I'm going to show that we are really working very hard to test the temperature, to test the catalyst they are putting, because before this they had two separate catalysts, one for Fischer-Tropsch to use the syngas, and the other one for the heavy oil to do the hydrocracking. Because what we aim to do is to produce not the heavy fuel that we obtain. We would like to convert it into a lighter fuel, and but free from sulfur, since it will be from agricultural waste, so we won't have sulfur, and it won't cause corrosion, it won't cause on burning the socks. And so they are, preparing the new one to upgrade the bio oil produced. They will do their own upgrading, and we will do our in Egypt. Okay, please, next. Also another, this is the future work they are thinking of to test the catalytic activity of the catalyst and adjusting the syngas ratio between hydrogen and the CO at different ratios, and the temperatures they are, and then down at the bottom they are thinking of the design and testing of the micro channel reactor. Please next. Yeah, and this is evidence of the publication they had in Sustainable Aviation Fuel Design, the workshops they have attended, and they have published two articles. Okay, and this is the equipment they have used. Please, next. Yeah. This is the IRSN. This is the timeline, the project timeline for them and the deliverables. And they are working on the theoretical foundation at first during all the 2023. Then they are proposing that they are aiming to do on the 2024 applied dimension. And then they will finish on the 2025, the practical facet, to have the environmental assessment and techno-economic assessment of the pyro-biofuel process, European and African case studies. Please, next. They have collected the data and on the transport, on the type of the biomass used. This is the literature review they are doing. And they are thinking of the feedstocks and then the process and then the end product at the end and the different fuels that they may obtain. We may obtain. And they are announcing, ils affichent the first results. And okay, for the time being, they did not submit a paper or a publication. Next, please. And of course, they are telling what they are doing and what are their next steps to the human resources who will join their team, the technician, the software, the pyrolysis laboratory purchase material, and that's it. Okay, please, next. Regarding the Ibn Tufayl University, what they want to do is that they have announced now they want to recruit a postdoc to work on the pyrolysis equipment. Even he may come to Egypt. Also, they will be doing they are waiting for our results to do the simulation and the modeling in the Moroccan side. What we see next is the flax fiber. They work on this in the CNRS. And they are it's a biomass, and they want to see with if they do the micro pyrolysis, how the fiber will shrink, how long it will stand the heat, and the effect, the thermogravimetric test on cellulose, of course, and hemicellulose. When I was in Paris a few days ago, I brought them flax fibers from Egypt to do the comparison, as well as some fibers from agricultural waste too. So they will be, they will, how to say it, they have also recruited a postdoc working on this, and it will be it will give good results. And at the end, I thank you for listening to my presentation, as well as I'm sorry again. I'm sorry for my late presentation. Okay, thank you.
So we will take the questions on this, your presentation of Pyro-Biofuels project. I think everyone is, yes, Anjali.
Thank you. So thank you for this presentation, but as we're looking at the midterm of the project, we didn't get a sense of the activities which have been done to date. You explained that there were some delays due to devaluation and delays in purchasing of equipment. So where do we stand now as compared to the initial work plan? and what are the next steps? Because I heard that your objectives were really to have a pilot project running. So given where we stand today, how realistic do you think this is going to be?
Thank you, Fatma, for a concise response.
Already I have the equipment now. We have received the equipment because in Egypt, I got the funds only in October. So we have started working from October 2022. And now we are in October 2023. And because of the devaluation, we had a very long delay. No, but we are working, we are not late. We have worked on this and we have done many results on small equipment, pyrolyzers we have, but we wanted to have the big the big pilot. And we have received this big pilot a month ago. So these are the photos of the pilot that we have already here. The South African counterparts, they will receive their equipment in November. The German counterparts are working. So we will have, we will work, we are according to plan. And we have published many publications. So we are not late. I don't know if I've answered the question or not.
Okay, I think you gave us some indication on the delay. I know there was it's one project with others who had some problems of funding from some funding agencies. We are well aware of that. But of course, if some amendment on the duration of the projects is needed, you have to contact all funding agencies and be sure, because LIPRI will end of 25, and we need all projects to be finished at least 6 months before the end of LIPRI. Is there other question? Or I see here everyone maybe is hungry. Okay, if not, thank you very much, Fatma. Thank you for the presentation. So we will resume this afternoon. We have we'll begin at 2:15. The lunch will be there, and we have a first session on new renewable energies with natural hydrogen potential, but also new solar cells designed for Africa climate. And we will have also a session on second life and end of life of renewable energy equipment projects and modeling. So we expect you at 2:15 sharp here in order to continue this midterm evaluation workshop. Thank you for all in the room and all online also. So see you at 2:15. Thank you.
And just as a minor housekeeping sort of item to clarify, today we are having lunch here at 4 Points. So we are not moving to Serena today, so we'll be just here. Yes.